Hey, hi everyone. Welcome back to my YouTube channel. My name is Sunny Savita, and I'm back with another exciting and important course for all of you. So, guys, in this particular video, in this particular course, we're gonna discuss about the Hugging Face. Hugging Face is a very important framework while we are learning generative AI. In the Hugging Face, guys, you will find out so many models, so many data set, and along with that, it provide you so many different library just to fine tune the model. So, guys, this course, this specific crash course is going to be a part of the LLM fine tuning playlist because in the upcoming video we're gonna learn so many concepts regarding the fine tuning like quantization and distributed training, the training using the path module, and in that Hugging Face is going to help us a lot. So first we'll start the fine tuning of the model from the Hugging Face itself, and then we'll move to the other framework. So guys, I hope you got to know the importance of this particular video. Now let's look into the syllabus, that what all thing we are going to discuss in this crash course, in this Hugging Face crash course, and guys, how you can proceed with that. So first of all, let me show you my YouTube channel, guys. This is the YouTube channel, and over there I uploaded 7 video related to the LLM fine tuning. Even though I didn't discuss so many things regarding the fine tuning, but I developed all the fundamentals over here inside this video. So if you want to learn the fine tuning from very scratch, then please follow this video. It will help you a lot to understand each and everything from scratch. And guys, in the upcoming session I am going to be discuss so many things with respect to this LLM fine tuning. So if you are not aware about the syllabus, you can go and check out the first video. I discuss each and everything over here. Now guys, let's look into the syllabus of this course. So here guys, I kept the syllabus in my notepad, and let me discuss one by one that what all thing we are going to discuss. So the first thing we're gonna discuss about the Hugging Face. I'll give you the quick introduction of it. Then we're gonna explore the Hugging Face ecosystem, that what all thing is being provided by the Hugging Face. Then guys, we'll see how we can log in. Okay, it's not logging actually, it's a login. How we can log in into the Hugging Face from the Python, using the Python, and log in. So let me write over here. And then the next one, create a repository manually or via CLI. So this particular concept also we're gonna discuss, that what is a repository in Hugging Face and why we should create that. Now guys, then we'll come to the dataset library. Dataset library is a library guys, which we can use for importing a different kind of data. Okay, so for sure we're gonna talk about it, we're gonna discuss about it. Then guys, we'll come to the data pre-processing and the visualization. So after loading a data, how we can pre-process that, how we can visualize that, each and every part we're gonna discuss over here. Then will come to the creating and uploading a custom data set. So if we have created any custom data set, then how we can push it to the Hugging Face hub. Then guys, understanding the tokenizer, which is a very important thing, very important part of the Hugging Face. Like before passing to the model, right? If we want to pass up data to the model, so for sure we'll have to be use this tokenizer over there, and I'm going to be discuss each and every part of it. Then guys, we'll see how we can train the custom tokenizer, each and every technique of the tokenizer, speed, performance, how you can optimize that, we're gonna see over here. Then guys, we'll look into the sentence embedding using the sentence transformer right after the tokenizer. Then we'll come to the different auto model class, like auto model, different other auto model with the different heads and all, like auto model LM, auto model sequence classification and all. Each and everything we're going to discuss, and we'll discuss about the auto configuration as well, that what is it, what it is, and why we should use it. Then guys, we'll come to the downloading model from the Hugging Face. If you want to download the model on your local server, how you can do that. Okay, so this part is also very crucial, and we'll see how you can download any sort of a model, and then how you can load that particular model. Then guys, we'll come to the pre-built pipeline. Okay, so there is a pipeline method which you can use directly from the transformer library. And yes, for sure, I'll show you. Visualization, attention with the word which, yes, I'll show you that as well. Then guys, model evaluation with blue score, rough score, and with the perplexity. So we're gonna discuss this evaluation matrices also. Then guys, we'll come to the Hugging Face REST API means. We'll discuss about the API, inference API from the Hugging Face and the complete Python SDK, that how you can utilize that particular API efficiently and how you can integrate inside your application. Then guys, the last part but not the least, that is going to be Hugging Face with Langchain, because everyone is going to be use Langchain nowadays and they want to be use the Hugging Face using the Langchain. So guys, all this thing, all this topic we are going to be discussed in this particular course, and I hope like you like the syllabus. So guys, yes, for sure we are going to be completed, and not only the theory, I'll show you each and everything in terms of practicals. So let's get started. So guys, this is the official website of the Hugging Face. So once you will write Hugging Face over the Google, you will get it. Now you just need to click on it and you will be directly redirecting to this particular website. Now over here you can see we have a various option like models, dataset, spaces, community, docs, pricing and all everything. Okay. So guys, it is see, if you will look into my syllabus, so there I haven't included most of the thing. So what all part I haven't included, for sure I'll try to discuss those things, and why I haven't included, I'll tell you that as well. Because in the upcoming videos, in the upcoming classes, we are going to be discuss those things separately. Okay. Now first thing guys, what I can do, I can show you the notebook which I created for all of you. So here this is the notebook guys. Inside this notebook you will find out the complete code which I created, and this notebook could be one stop solution if you are starting with the Hugging Face. Okay, many more things I have included over here. So first of all, let me do one thing. Let me give you the quick recap of the or quick overview of the Hugging Face platform, and then for sure I'll come to this notebook and step by step, one by one, we'll try to discuss each and everything. And again I'm saying guys, this a particular topic, Hugging Face, okay, I have included inside the LLM fine tuning playlist, so that guys, later on whenever I'm going to discuss anything with respect to the Hugging Face, so easily you can refer, easily you can understand. So that's why this video, this course is very much important. Now first of all, let me do one thing. Let me give you the quick recap of this platform. So guys, once you will click on this models, you will get all the models. Okay, so this is a open source community, and here you can see there is a different like filter which you can apply, and based on that you can select a model. Now guys, similar to the model, we have a repository for the data set also. So there is around 4 lakh data set, more than that. So there is a different data set which you will get over here, and for sure you can look, you can download the data set according to your requirement. You can utilize it for your learning, for your fine tuning and all. There are so many things you can do using these data set. And here is a modality as well. Some filter have been given. Use this filter and according to your requirement, try to utilize the data. Now there is a space guys. So space for what? Space for deploying a model. So you can create your own space, and you can create your own application, means you can deploy your own application. So here you can see guys, all the application which was deployed by the community. So whoever kept their application as a public one, you can look into their application, and guys, this could be a very good example, right? Or this could be a very good resources for your learning. You can go through with this application, and you can look into the new use case, and even you can implement that. So here is some filter option. Please try to select any of them, and according to your use case, okay, try to learn the stuff, or try to take a project idea from here itself. Then guys, there is a community. So community wise, whatever blog, article, posts have been published by the Hugging Face, you will see everything over here. Now guys, the main part of this particular Hugging Face website, that is doc guys. Okay, so this is what I was talking about, like the different other library. So let me show you that what all library this Hugging Face is having. So guys, the very important library is Hub. Okay, not very important, but yeah, if you want to be interact with this GitHubs. If you want to be take a information of the model data in a Pythonic way, then for sure you should go through with this particular library. Then there is a Python library. Okay, this two library is an important one. You can look into it. Even I will show you this Hugging Face in my code as well. Then guys, the next library, which is a transformer, the most important library, and for sure we're gonna learn that. We're gonna learn about the dataset as well, and we're gonna learn about the evaluation as well. So there's three things: transformer, this tokenizer, dataset, and evaluation. And even I will show you this sentence transformer as well for embedding and retrieval. I'll show you how you can perform the embedding using any sentence transform based model, and for sure this is going to be a part of this particular course. Now guys, the advanced part of this document will come, that is a PAP, okay, accelerate, and this TRL, right? So this bits and bytes also. So this all the thing, this all the library which will come in a future classes. Okay, so I haven't included this part because anyhow I will show you the fine tuning using the Hugging Face, and this module will come over there. So intentionally I haven't kept it over here. Then a small agent for creating a agent, then Gradio like for integrating the UI and all, right? Build the interactive application using this Gradio. Okay, now auto train is also there, which was like introduced recently. Leaderboards are there. So these are a couple of extra library which we can discuss in the upcoming session, right? But this section is very much important where I will focus more. And this particular section like transformer, tokenizer, evaluator, sentence transformer and all, this all the thing I'm going to discuss in today's session along with all the how and all. I hope guys this idea is clear. Now let's do one thing. Let's look into a couple of more things. So guys, once I will click on this Hugging Face, right? So after clicking on this Hugging Face, guys, so here is my profile. So once you will sign up over here, so after signing up guys, you will be getting your profile. So see, this is my profile. Now here along with the profile, you can see there is a couple of options. So new model is there, new data set is there, new spaces is there, new collection is there. Okay, now apart from that, couple of more indicator, private storage, like how much storage it is providing to me, zero GPU, right? Did I use the GPU, the free GPU or not? Inference usage, so did I use any, did I like use the inference API? Okay, did I load any sort of a model from the Hugging Face itself? Just to like perform some prediction and all. Okay, so here you can see the limit of it. So Hugging Face is providing you the free access as well as it is available in the paid one as well for the enterprises and all. So yeah, that thing also we can check. Now guys, the main thing of it, access token. So we are going to be generate a multiple tokens. Okay, read token, write token, and even we have a fine grade option. So if you want to give the specific permission to someone, you can give from there, right? So there is a couple of option guys. Now what we have to do, we have to understand all this thing: new model, new data set, new spaces, new collection, and we have to be like understand like what is this Hugging Face, okay, and what is this Hugging Face repository. And apart from this one guys, we have to understand about the dataset repository, spaces, like the collection and all, everything we're gonna see over here. So what I'm doing guys, first I'm giving you the quick definition of this each and everything, and then I will come to the practical. Okay, step by step, one by one, we'll try to implement each and everything. So over here guys, I capped some definition and all so that you can understand the Hugging Face in a easiest way. So what is a Hugging Face? So Hugging Face is a platform where you can build, share and use AI model and dataset easily. So it's a kind of platform and the ecosystem which is providing you the model and the dataset, so that you can directly use from there. You can build the application and you can share with everyone through the Hugging Face space. Now guys, there is a couple of more points. So there is a thousand of model for the NLP, computer vision and the generative AI, the recent generative AI and all. Then guys, you can create and host apps for free using spaces. As I told you, it provides you the open source tools, framework, library like transformer, dataset, accelerator, accelerate, PAT, TRL, bits and bytes. So guys, this will help you a lot to develop a AI application. Now guys, why Hugging Face? So Hugging Face, see, using the Hugging Face, we can make AI accessible, open and easy for everyone. So guys, if you will look into the early stage of the AI, like 2018 and 19, so at that time we were not having an exposure of so many model, right? We were struggling to get our resources and all, right? And couple of thing, like couple of framework only were helping to us. Then this Hugging Face Cup, you know about the GitHub, right? So over the GitHub, you will find out the different report, different kind of project, different kind of code, and that is a bigger help for every software or every AI developer. So similar to that, guys, with that same idea, this Hugging Face came into the market. They have open source. Okay, they have open source this model and this data set for everyone, so that everyone, right, every developer can access it and can build the application on top of it, on top of the AI models, right? So earlier they were more focusing on the NLP, and then slowly and gradually they capped their leg in every sort of a like the modality and every sort of a stack and all. So guys, there is a very like a small difference, right, between the Langchain and the Hugging Face. See, Langchain is providing you the complete ecosystem for developing the Gen AI, mainly the RAG and the agentic based system. Okay, so it is providing the prompting, it's providing you the API integration from the different model, it's providing you the different tool integration, it's providing the chaining concept, right? Apart from that, prompting, I already said, LangGraph for the agents, okay, LangSmith for the tracking and all. So guys, see, LangChain is more towards to build and productionize the application, mainly the LLM based application, whereas this Hugging Face is providing you the model as well as data and the library and the framework for the fine tuning. Understood, guys? So it is having, see, there is a differences between the Langchain and Hugging Face. Hugging Face is a platform where you can upload the model after the fine tuning, or you can download the model. Okay, like whoever has uploaded that. If there is a private repository, then you will have to ask a special access for it, right? And it is providing you the data set also. Data set means, so if you want to train your own model and all, and it is providing you the libraries for fine tuning the model also from scratch. Okay, whereas Langchain is not providing you the way where you can download a model from their own platform. No, you have a API integration. You can integrate Langchain with a Hugging Face. Okay, Langchain is not providing you the basically this one data set. Okay, you cannot like download the data set. Langchain is not providing the support for the fine tuning, whereas Hugging Face is providing you that. So there is some differences between that. We'll see how we can access the Hugging Face using the Langchain. I already capped in my syllabus those that particular concept. So guys, over here you can see I written couple of things. So new model, new data set, new spaces, new collection, and some other thing. So first of all, guys, before coming to this particular option, we have to look into this node that which I mentioned. So whenever we are going to be create, okay, whenever we are going to be create any model, any data set, any space over the Hugging Face hub, that means we are going to be create a Git repository under my user name. That's it, guys. Okay, so it just a manage through the Hugging Face web interface. Means you are going to be create a Git repo. Okay, while you are going to be create any model or data set, means you are going to be upload your own custom model or data set, or the your application via spaces. So that is nothing. This is that's going to be upload over the GitHub repo itself. But Hugging Face has provided their own interface to this GitHub repo. Okay, that's a simple hack. Now, whenever we are going to be click on this new model, new data set, and new spaces or new collection, we are going to be build our repo. There we can upload our model, our data set, our application. Collection means collection of the multiple model, multiple data set and all. Create organization. We can create organization, means we can create a shared workspace and multiple member can work with multiple member can work all together. Then there is a private storage which was given by the Hugging Face freely, 100 GB of space for developing, for keeping any model, any data set, or for deploying any application. GPU limit is there, only for 5 minutes you can use the GPU. Okay, in the free access, in paid one you can use maybe according to the time, right? According to the pay. Now inference uses, so yes, inference API is also there. So if someone has deployed their model, you can directly use it through the inferencing API. You no need to like download on your own infrastructure. Then pro access is also there. You can check out with their pro access if you are using this Hugging Face into your enterprise in your organization. Access token, it is providing you the access token for accessing the models, downloading the models, data set, right? For accessing the library framework and even for uploading the data model on their own GitHub repository. Now, guys, let's do first thing. Let's try to look into this particular options, right? What all options is there over the Hugging Face itself. Then we'll come to the basically practical. Okay, so for the practical, guys, I created this entire notebook. This notebook for all of you guys, and for sure I'll try to discuss each and every part from here. So here, guys, you can see this is a like Hugging Face. Now, if I'm going to be click on this option on icon on my profile icon, I'll be getting this option. So let's say if I want to create a new model, okay. So this here what I'm doing, I'm going to be create a repository for keeping my model. So let's say if I'm going to be write testing my testing model. Okay, so license I can provide any license. It is an open source one, so I can give Apache license, and I'm going to keep it public or private. It's up to me. Then I'm going to be create a model repository. Okay, so inside this repository I can hold my model. I can keep my model. Now see, it is giving me an option like how you can upload a model. So via CLI there is an option like you can upload the model. Here is a Python. Okay, so via Python you can use this Hugging Face of HF API, and you can upload your model. I'll show you this thing in the upcoming in the upcoming in this tutorial itself. Okay, and in the upcoming session we are going to be fine tune the model, and that time again I will show you this part. So how you can push your model. So see, I created one repository and my repository is available over here. If I want to check how I can check, I just need to click on my profile. I'll be getting all my repository. So see, just now I created my testing model repository, and see, this is all the other repository which I created earlier. After the fine tuning and all, I have uploaded my model over here. Then there is a dataset repository, guys. Similar to the model repository, you can create a dataset repository also over here. And this all the thing you can do using the CLI as well as using the Hugging Face API. Okay. Now, guys, you can see I have a spaces also. So I have uploaded my application over the spaces. You can also train and you can also upload. So this part also we're gonna see in the upcoming session. Okay, so model, dataset, spaces, I think everything you understood. Now, guys, once you will click on this profile icon, you will get an option of this collection. Collection is nothing, it is a collection of all the thing at the single place. So you can create a collection as well, and everything will be available at the single place for you. Now, guys, when you once you will scroll down, you will find out one more option. That option is the access token. Okay. Now, once you will click on this access token, guys, there is a like way of creating a token. The other ways is also there: authentication, organization, billing, and the SSH, inference provider, Webho. So until you are not using it on an enterprise level, means inside your real-time application, you no need to go through with this each and every option. If you are going to be like a work in your real-time application, then choose the option accordingly. Like let's say you want to be access the SSH. Okay, you want to be check with the multi-factor authentication and all. You want to be like check with the webhook call or this inference provider and all. Then go step by step according to that. But as of now, guys, we have to be checked with this access token. So just click on this access token. You will get a way of creating the token. See, here is the option of creating a token. Now click on it, click on this token, and you will see the three option over here. First is the fine grid option, means you can customize the permission over here in the fine grid, right? So whatever regarding whatever thing you want to be provide the like the access, okay, you can do over here. Otherwise, you can simply give the read like a permission. You can generate a token with respect to the reading the model and the data set and all. If you want to write something on top of the Hugging Face repository, in that case you will have to generate a write token. So read token, write token, both are important. Now how you can do that? You can simply like write a name of the token. Let's say here I'm going to be write live Hugging Face HF session. So see, I will be able to generate the read token. Okay, so you just need to copy this token and keep it with you. Then, guys, likewise you can create a write token as well. And write token for keeping the files and all everything on your Hugging Face itself. Okay, so using this write token only you can keep it, otherwise it will give you the issue. So guys, I hope everything is clarified with respect to this Hugging Face, with respect to this Hugging Face repository, with respect to this token and all. Okay, how to create, how to generate a token. Let's say if I want to generate a write token, now again give the name to live testing. Any name you can provide over here, it's up to you. Now here you can generate a token and see this is the token. Now copy it and keep it with you. If you are going to be like not copying, then you will lose the token. Again, you will have to generate that particular token. Okay. So I hope this thing is again clear. Everything is perfect. Everything is fine. So let's start with the coding. Let's look into the practical implementation of each and everything, guys. So for the practical, guys, I already created notebook. I just shown you that. So let's see how we can log in to the Hugging Face from the Python, or in a multiple ways how we can log in. If you are going to be use a script, Python script, or if you are going to be log in from the CLI, or if you are going to be log in from the notebook, that what all ways we have. So first of all, you will have to connect with your GPU. See, if you are going to work with the CPU as well, that is also fine. I don't. So as of now, we don't have any requirement of the GPU, but later on we'll switch to the training and all. At that time, for sure, we're gonna use GPU. And even I will show you the updated GPU as well, like A100 L4 and all. I'll purchase the Google Colab Pro, and there we'll show you the training with the updated GPU. So guys, now what I'm doing, I'm just saving it as a GPU as of now, and then I'm going to be connect. If you don't have a GPU currently, means if you are going to be exceed your limit or something, then no need to panic. You can work with the CPU as well. Okay. So first thing, guys, first and foremost thing, I'm going to be install this Hugging Face Hub. So what is this Hugging Face Hub? We'll discuss that in a very detailed manner in my this video itself. I kept it in the syllabus. You can recheck it. You can go back and check that. So here I'm going to be install the Hugging Face Hub. See, the Hugging Face Hub is getting installed. Now for the login, guys, we have a different way. So first is a CLI method. So I can log in with the CLI, Hugging Face CLI login. The second is basically from the Hugging Face API, HF API, and this is also available in Hugging Face package, Hugging Face Hub package. The third one, which is a Hugging Face. Okay, from the Hugging Face Hub itself, there is a login method. So this particular way I'm going to be used inside the Python script, and the last one for notebook. So if I want to be log in through the Jupyter notebook, so I can utilize this particular notebook login, and I can do that. So guys, the first one for from the CLI, okay. The second one basically to the simple Hugging Face login, like using the HF API to access the different model, or to perform the inferencing, to load any model from the Hugging Face Hub directly, okay, without keeping it inside the local memory. Then the third one for the script, if you are going to be write a Python script, then for logging in, you can utilize this particular method, login directly. And for the notebook login, there is a way. So what I'm doing, guys, so here I have generated a token and I kept it in my secrets. So if you look into my secret, guys, so I have a token. So the token name is a HF token. Now what I can do, I can show you how to generate this and how to keep it over here. So I'm going to be generate two token as of now. First is a write and the second is a read token. Okay, so just click on this create new token, and then you will get an option of it. So see, first I'm going to be generate a read token. So uh, testing live read. Okay, you can write any name. This is my name, testing live read. Now I've created a token and I copied it over here. Now what I'm doing, guys, so inside this Hugging Face, inside the notebook itself, I'm going to be create a new secret. The secret is going to be HF token, write, or read is this one, na? So read, read. I'll pass my token value over here, and see, this is the read token. Now I'm going to be create one more over here. The token is going to be write token. Okay, so here I will be writing HF token write. So let me take this write token as well from here. So here I'm writing testing live write. So testing live write. So this is my token name. Don't give the space, write without a space. So let me generate it and see it is generated, and I'm going to be copy and paste in my collab again. So here HF underscore token underscore write. Okay, now here I will keep this particular token value. Now see, actually it is going to be take this HF token only, right? But whenever we are going to be load anything, then we'll be required a read token. But whenever we are going to be write something, then we require a write token. So in between I can switch. That's why I kept this two variable also, separate variable. But by default, guys, it will be taking this HF token only. So let me do one thing. Let me keep this read value over here in the HF token. So by default, whenever we are going to be whenever we are going to be import anything from the Hugging Face, or running anything now, so by default it will follow it will follow this HF token only, this particular variable. Okay, Now let's do one thing. Let's try to run the code. So HF token is clear. Now here I'm going to be login. So first guys, I'm going to be import this user data, okay, from the collab, and using this user data I'm going to be read both of the token. First is a read token. So here see I have a read token, and the spelling is different, so let me write the correct spelling over here. It is going to be HF token underscore read. Okay, so this is my token. Now see if I'm going to be executed, so I'm getting a value of it. So let me print this read token and see here what I have. I have a read token. Now let's say if I want to be get a write token, so simply I will take this word from here, this write. Okay, and I'm going to be cut it because my token name is different. So I'm just see, you can keep any name over here regarding the token. I just kept HF token right. So see if I'm going to be printed, so see this is my like token. Okay, now if I want to be login through the CLI, so this is a command for that, hugging face CLI login. But yeah, before that you will have to be execute this part so that it can like take that hugging face credential and it can utilize for the GitHub as well. So I'm going to be execute this command git config hyphen global credential dot helper dot store. Okay, so it is just a helper one for the helping one basically. So so it can store the credential of the git. So let's say if I'm going to be execute this one hugging face CLI login. So what it will do, it will ask me a token. Okay, so simply you can give the write token or read token anything over here. So let's say if I want to be give the like this read token. Okay, so I will simply see from here also I can take this is the same one, right? So I will be passing the token and then after that it will give me one more option. So add token as a get credential. So for that only I was running this particular command, this config credential helper store. So what I'm doing, I'm just writing yes over here, yes, and once I'll write yes guys over here, see this one, and I will press enter. So see everything is working fine, means I'm able to log in to my hugging face. Okay, so I'm able to log into my hugging face. Now if I want to check who I am, I can simply run this command and I'll be getting that. Now for this one you will have to use the token with the right permission. So see from the CLI itself directly I'm going to be create a repository. So as of now I logged in through the CLI with the read token. Okay, but if I want to be create the repository from the from the Python sorry, from the terminal itself, so in that case you require the write token. So what I'm doing again, I'm going to be login with the write token so that I can show you how we can create a repository. Okay, so HF token, right, let me copy it from here and after that I can pass it. So see my token is getting passed. Now if I will run it and see if I will pass yes, so yes, I am able to log in successfully. Now I can check who I am. So I am Sunny only. Okay, so see this is giving me a username, and after that guys see hugging face CLI. So this is my command hugging face CLI repo. I'm going to be create a repo. Okay, the repo name is dummy. Let me write some other name. So live hf codes. Okay, live hf codes, and see once I will run it guys, I will be able to create a repository successfully over the hugging face hub. You can check it out. You can simply go through with your profile, and inside the profile itself you will be able to find out this particular repository. See Sunny live hf code, this repository is over here. Now I can keep anything over here inside this repository, it's up to me. So I will show you that particular part as well. So yes, likewise we can create a dummy, this dataset also, dataset repository. So I can write live hf data codes. Okay, so any name you can write. So if I'm going to be executed, see successfully I'm able to create a repository. Now you can check out with the hugging face. So over the hugging face itself you will get that, and you can keep anything, any sort of a data over there. So models is there, as I shown you, this is the data set repository. Now likewise you can do many more things. You can create a space also. Okay, but here you will have to be mentioned for which occasion, sorry, for with which technology you want, like Docker or Gradio or any other one. So I think simply you can mention that and you can test it out. So guys, if this thing is clear, I think we can proceed with the next one, which is going to be a like the second one, second option. Okay, the API option, HF API option. Guys, you can read the token, HF read token, or you can read the write token. Both token you can read and write, as I shown you over here. So read token was there and write token was there. So I no need to write it again. I'm just going to be remove this one, and simply I can check via print. So whether it is showing or not. And guys, this is going to be important. Okay, this read and write token. So whenever you have to write something over the Hugging Face, so for sure you will have to be use it. So now let me check out with my read token. So both is fine, both is there. Now here is my Hugging Face API, HF API. I'm importing it from the Hugging Face hub. So let me execute this one. Now what I'm doing, guys, I'm going to be create an object of this Hugging Face API, HF API. See, here is our object. And in the object, while I'm going to be create an object, I'm passing the token, this write token. Okay. So here is what? Here is my API, which is created. Now from the API also I can create my repo. So let's say here I want to create my repo Sunny repo. Okay, now I'm passing my repo type. It's going to be model. I'm just going to be keep the model, and here is a private is false. So it is a public for everyone. I can keep the private also. Both are fine. If I'm going to be executed, guys, so here you will be able to see my repo is created. You can check out with that particular repo. It is there under the Sunny Savita. So under the Sunny 199 username. If I'm going to be refresh it, I'll be getting that one. Okay. So see, guys, live HF course. This particular notebook have been created from here. Okay. So now, guys, see. Okay. So Sunny 99 Sunny Repo. Okay. I think let me check out again. The exact name. I think it's not going to be refreshed. Let me refresh it one more time. So yeah, Sunny Repo is here, guys. Okay, so sorry, I forgot. I didn't refresh that, and I hope this part is clear, like how this thing is working. Now, if I want to be upload any file, so yes, I can upload any file to the repo from our local itself. So see, create repo. We are passing repo ID, repo type, and private. Private is false. Now upload file. I'm passing the path of the file where the file is available. Path in repo. Okay, where it will be available in the current repo itself, and this is the repo ID. So I have to use this particular repo ID, Sunny repo, and let me keep it over here. Okay, so I'm just going to be replace this repo name, and this is my username. This is the permanent one. Now what I will do, I'll create one test file, this particular folder. So here inside this test, okay, test file. Okay, inside this particular folder, I'm going to be keep one uh, file. Okay, the file name is going to be what? So the file, sorry, it's not a folder, guys. It is going to be a file only. So let me delete it. Delete. Okay, this is fine. And after deleting it, guys, let's do one thing. Config.json. Okay, so config underscore json. It's not going to be take that. Just a second. Let me again. Okay, config dot json. Okay, now see, guys, I created this particular file. It will check with whether this is available or not at this particular path. So here is a like the path in repo. So where it will go in the repo, it is indicating that it will be residing in the current repo itself. And then here is a repo ID. If I'm going to be executed, guys, so here see my code is committed. My code is sorry, my file is done. My file is committed, so I can check out with my repository. See, here is a repository, and in the repository itself, okay, so here just a second, let me show you. In the repository itself, you will be able to get that particular file. So see, config.json is there, and just now I have uploaded that. So similar to this one, you can do you can upload any sort of a file, okay, to the Hugging Face repository. Now third way, via login method. So directly the one login method is also there. You can call this login, and with the read and write token with whatever permission you want to be create that. So here I'm going to be login with a read. I'm going to be login with a write. You can check it out. Now notebook login. So whenever you are working with the IP bind B, so here you can utilize a notebook login. You just need to pass your token. Okay, after the login, and guys, see how it looks like. See this like this. It looks like. Okay, so it is just asking a token. So just provide a token, and in that case, you will be okay. Just provide a token, and then you will be able to read a model. You will be able to write a model, write a data set, read a data set. Okay, and many more things with respect to Hugging Face you can do. Now, guys, let's look into the dataset library. I think rest of the part is clear. Now, I hope so, guys. You will go through with this code, and you will make your understanding little more concrete. So let's begin. Let's start with the dataset library and see what all thing I've kept over here for all of. So first guys, we'll have to install this dataset library along with this one more library, that is file system specification. Now this library actually, it's a supporting library. It will help you to fetch out the data from anywhere, from any cloud, from any cache, or from any hub. So I already installed this particular library, and here I written a command pip install -u dataset, and other one fss pec. So hyphen U is representing to the updated version, or to the latest version of this data set, and this FSS PEC library. Now guys, here what I'm doing, I'm going to be load the data set. Okay, so I have imported this load data set function from this data set itself. Now to this load data set, I have passed yeah, I have passed the basically repo ID of the data set repo. So there are so many data set you will get over the Hugging Face. So once you will go and check with the Hugging Face platform. So and once you will click on this data set, there is around 4,32,752 data set. Now there they have given you the different modality also. So let's say you want to work with the video data set. So once you will click on this video, you will get the video data set. Okay. Now once you will click on this tabular guys, you will get the tabular data set. So you can check out with this tabular data set, different tabular data set. Then once you will click on this document, so you will get a variety of the document. So images is also there, image data set is also available over the Hugging Face. So variety of the data set, and they have given you one more filter, the size of the rows. Okay, so you can check out with the size of the row, you can check out with the format and all. Okay, so I'm going to use this IMDb dataset just to showcase you like how to load the data, as well as how to do some pre-processing on top of it. So guys, once you will scroll down, you will get the data itself. Now once you will scroll down more here, you will get the complete detail of the data set, description and all everything. So you can check out with the repo, like a specific repo. And don't worry, we are going to be like update our own data set as well over the Hugging Face data set repo, as I shown you like just now, that we can create our own repo with respect to the data set, and we can upload our own custom data set over here. Now what I'm doing guys, so over here you can see I'm going to be load the data. So load the data set. So guys, my data set is getting loaded, and I will be keeping inside this particular variable. Now what I will do after loading this data set, it might take some time, so no need to worry, because the data set might be little huge. And inside this data set itself, you will find out there is a 25,000 rows. Okay, and this row basically it was splitted into the multiple section like train, test, and the unsupervised. So you can print this variable, dataset variable, and here you can get a detail of this particular dataset, like we have a train, we have a test, okay, and we have a unsupervised dataset also. So here I written a detail of it. So train means what? For the training. Test means what? For the evaluating. Okay, and unsupervised means there is no clean label inside the data. This is used for the pre-training or self-supervised task. So let's say if I want to perform any pre-training, okay, so for the pre-training also I can utilize this section of this IMDb dataset. The section is called unsupervised section. So here what I'm doing guys, I'm going to be check with the first row of the data of the train data. Okay, so here guys, if I'm going to be remove this 0, you will find out the train data. Okay, so there is 25,000 row. Now if I want to be print the first row of this train data, how I can do that? I can simply put the 0 over here. So once I will put the 0 guys, I'll be getting the first row, and see this is the text. Okay, now if you want to check out the other detail of the train data set, so this is couple of more features, more parameter which you can call. So we have a feature, we have a column name, we have a features label name. Okay, we have a like number of rows, number of columns, shape and all everything. So once you will print it guys, here you will get the complete detail. So here is our features. We have a feature like text and label. Okay, two feature itself. Now inside the label itself, we have a two classes. First is a negative and second is a positive class. Then we have like column name, text label, already clear label. This is already clear. Number of rows 25,000, number of column 2, and this is the shape of the data. So this kind of thing you can get with respect to the data for the basic analysis and all. Now coming to the next part. So guys, if you want to take a random data, okay, from your data set itself, so you can call this shuffle on top of it. So once you will call a shuffle guys, you will get a shuffle data, you will get some random data. Okay, the data is going to be shuffle. So here let me show you. So this is the shuffle data guys. The size would be same, but here the shuffling would be there. Okay, shuffling means the random arrangement of the data. Now here guys, what I'm doing, now let's say if I want to be like give any seed value to the shuffle, let's say for this let's say I again if I'm going to be execute this one again and again, and I will be getting a different arrangement of the data, but I want to be keep it same, okay, for one specific ID, for one specific seed value. So that also we can do. So here I mentioned the seed value, seed is equal to 42, and for this particular value throughout this execution the data set would be same. Okay, so here guys, once I will check with the shuffle data, I will be getting shuffle data. Okay, and as many as time I'm going to be execute for this particular seed ID, I will be getting a same kind of data. Okay, now I hope this is clear. So guys, here if I want to take a subset of the data, okay, random 100 sample from the data set, so simply I can call this shuffle dot select, and I can provide the number of data points, how much data we want. So if I'm going to be execute this one and see the number of rows is 100. Here we have a feature is text and label, and I'm getting 100 random rows from my data. Okay. Now here what I did guys, I just took 5,000 sample, 5,000 random sample from the data. So I'm using a same technique. We have a data set train. We are going to be use shuffle. We have mentioned one ID. For this particular ID, the random sample is going to be same for every time, for every run. And here you can see 5,000 rows we are going to be select. Now guys, once I will execute it, so here you will be able to get the 5,000 row, the random row. I hope this thing is clear, like how to take a random data set. Now coming to the next part over here. So guys, here what I'm doing some pre-processing on top of the data. Now what kind of pre-processing I'm doing over here? So see, we have a data set. We are going to be we are going to be take a train data set, as you can see over here. Okay. Now on top of it, I'm going to call this filter method. So dataset train dot filter, and here I'm going to be check the length of the reviews. If it is less than 100, so those review only I'm going to be keep inside my variable. Okay, so if I'm going to be executed, so here you will find out there is a 9 review in total which is having length less than 100. Okay, now I just check with the subset train, means on top of this random data set which I picked, okay, from the main data set itself, the 5,000 rows. So on top of it also I'm going to be check some I'm going to be put some filter. So here I'm doing one thing. I'm taking this dataset train. Okay, not this one guys, this one. So what I'm doing, I'm going to be take this subtrain, and on top of it I'm going to be call a filter, and here is my point. All the data point will come, and I'm going to be check the length of it. Okay, if it is less than 100 guys, so I'm going to be print all those data points. So in this particular data set, in the 5,000 rows, I have only 2 rows which is having length less than 100. Now I can put some more condition. So here again I took the original data set. On top of it I'm going to call the filter, and now I have putting two conditions. So first, label is equal to true, and the second is basically length is less than 200. So if I'm going to be check with this kind of the if you are going to be check with this kind of filtering, so how many total rows I'll be getting? I'll be getting 16 rows, which is having like a less which is having length less than 200, and the label is true. Okay, I hope you understood how to perform the I hope you understood how to perform the filtering on top of the data set. Now guys, a couple of more filtering thing I am doing over here. So I have a add word count. Now what I'm doing, I'm going to be check. See, what I'm doing, I'm going to check the length of each and every sentence. Okay, means length of each and every sentence, how much basically tokens we have over there. So for that, what I'm doing, I'm taking a sentence first. I'm taking a first review. I'm calling this a split on top of it, and then I'm checking a length. So I'm checking like how many words we have in the particular sentence. Okay, in the particular review. So let me execute it, and let me bind this particular function, this add map word count, with my data set. So here is my data set guys. To on it to this particular data set, I'm going to be call this map, and here I'm passing this method, this add word count. Now once I will execute it guys, I'll be getting my data set, and inside the data set one more column will be appended, and the column name itself is called the count, word count. Okay, so if I want to check the word of like how many words is there in every sentences, so see here I'm checking it. So in the first sentence, in the training data, of like in the first sentence of the training data, the total number of word is 288. In the second one we have a 214 words, and in the like third sentence we have 93. So likewise you can iterate the for loop, and you can capture the like number of word in every sentences. I hope it is getting clear to all of you. It is very easy pre-processing and all. Now coming to the next part over here. So guys, not only this IMDb dataset, we can import any of the dataset. Even though I kept some dataset link over here, sorry, dataset name over here, which is a quite popular dataset. Okay, so I can show you that particular those particular dataset over here. So first is the IMDb dataset, which is for the movie review. Then AG News, Squad, Glue, Colner, Yelp, Amazon, Multi, NLI, Tweetable. Okay, so this all the data set, the list basically which I keep. The this is a very famous data set in their like for with respect to their own like the task. Okay, so some of them for the NLP, some of them for the speech, some of them for the vision translation, and for the different other modality and the task, right? So likewise, guys, you can go through with each and every data set, whatever I mentioned over here, and at least you can understand that what they have providing over there. Right, now guys, couple of more thing I have mentioned over here. So here I'm going to be use the streaming true, which is very important to take care the huge data set, the large data set. If the data set is not fully downloadable, in that case, what you can do, you can stream that particular data sample by sample, right? So data like C4, the pile, the open web text. So these are very huge data set. This particular data set is having tokens in billions, and the size of the data set again in GBs. So that's why, guys, what I'm doing, I'm going to be stream this particular data set. So if I'm going to be executed, guys, so see, it is able to take the data set from the Hugging Face, and I'll be getting this data inside this particular variable. So it is asking to me, like, do you trust on this repository? I would say yes, I trust on this repository, and with that, guys, I'm able to load this data. Now, once I will load this data, guys, so here you will get a detail of this data. Okay, so there is a train feature, and this train feature is a iterable feature. Okay, and the number of thread is 21. So what is the meaning of this number of like threads? So just look over here. I kept each and every detail. Iterable dataset means a dictionary like object with a split. Okay, means we are just getting a test data train dataset. So here you can see feature text means we are just getting a text column of it, and then number of thread 21 means internally it is going to be chunked into 21 streamable part. Okay, this entire dataset. Now over here, this open text open web text data set, it is having around 8.13 million document. The total token size is 40 billions over here, and the total size on disk is 38 GB. So this particular data set basically have been used for train the GPT kind of model, GPT-2 and the further GPT based model. Okay, I hope this thing is clear to all of you. Now if I want to check the top 5 rows of this data set, I can simply call this take on top of the data. Okay, take 5, and then see here is the top 5 rows of the data. I hope this thing is clear. So likewise, you can take any sort of a data and you can analyze that particular data. Now there is one more data set, guys, which I'm taking. So the data set name is C4. So the name is it colossal clean crawled corpus from full form. Okay, it's a full form of this C4 data set. Colossal clean crawled corpus. Now this data set again was used in many of the model, right? In many of the pre-training, and mainly it was introduced in T5 paper, research paper. Okay, so here what we are doing, we are going to be load the English version of this data, and here we are going to be split into the train. We are just going to be take the split part of this data set, and here the streaming is equal to true, means we are going to be not load the entire data over the disk. Instead of that, we are going to be fetch this data into the patches. Okay, yeah, we are going to be stream this data in a different batches, right? So here, guys, again, if I want to take like top 5 rows, so yes, I can take it over here. So see, I'm iterating a for loop, and when it is like less than if it is greater than 4, until unless see, if it is greater than 4, until unless it is not going to break. So how many rows I'm getting? So I'm getting total 6 rows. Okay, so I'm just getting top 6 rows over here, as you can see, like using this particular logic, but you can get as many as rows over here. I hope this thing is also clear. So I'm just showing you the different data, and if you are going to be load any huge data, big data, now how you can take care of it. So that's what also I'm additionally adding over here. Now coming to the next part. So the next is a tweet eval. So this is also one of the data set which is basically for the for the sentiment analysis. So I'm going to be load this data. I'm passing this tweet eval over here, this key, and here is what, here is my sentiment. Okay, so what is the meaning of the sentiment? So sentiment means we are going to be load those specific label. Okay, this database basically it's for the sentiment analysis, and we are going to be load only those specific label regarding this tweet and all. Okay, so this is some inbuilt like the detail which we can pass over here regarding the data. So first is the ID, and the second is the description of it. Now, guys, what will happen? So see, if I'm going to be executed, I will be able to get this particular data. Now I can check this data. Okay, so here we have what, we have a text. uh, uh, Basically what we have a three column itself. First we have a train, second we have a test, and the third is a validation. Now you can see the number of rows as well, and here see the detail of this particular data. So truth table is a dataset collection for the Twitter NLP. Sentiment means subtask sentiment classification, and here the label 0 means negative, 1 means neutral, and second means positive. Okay, so and for which use case we are going to be take this particular data? We are going to be take this particular data for the sentiment analysis. I hope guys this data loading and all everything is clear. Now coming to the next part. So how you can perform the visualization of the data. So for the visualization guys, we can do the analysis visualization in the same way like we were doing in our core machine learning and the NLP. So here what I'm doing, I'm going to be take this data set. Okay, so here see, we are going to be iterate on top of the trained data set and we are going to be keep it over here. Okay, so this is the labels actually from the trained data set. Now what I will do, I'm going to be print the label. Okay, so how many negative numbers is there, how many neutral is there, how many positive number is there. So this kind of this kind of data visualization you can perform for the better understanding of the data. Okay, now I have kept couple of more plots. So over here guys, you can see what I'm doing. So I'm going to be iterate on top of the trained data set and we are going to be keep a label over here and see this is the label. Now what I'm doing, I'm just checking with the count of the label. So once I will execute it, I'll be getting a count of those particular label. Now what I'm going to do, I'm going to be plotted using the pie chart. So here I will get the clear cut percentage of each and every label. Okay, so how many positive document is there, how many negative document is there, how many neutral document is there. I hope guys this thing is also clear. Now coming to the next part, so next visualization. So what I'm doing over here guys, again I'm going to be iterate on top of the text data. Okay, now after that see we are getting all the words and all. Now after finding out all the words from the trained data set, now what I'm doing, so see this is my top words. Okay, now I'm going to be visualize that. So what all what is the top 20 most common words in a tweets. So likewise guys, here you will be able to find out top 20 most common words. Okay, so the is coming I think more than 100 800 times, then to is coming, then user is coming, then I in on. So guys what I did, I just took the test data set and on top of it guys what I did, I applied some logic and all and I find out all the words over here. Now after that guys, I'm going to be print this word using this bar chart and I hope so this thing is also clear. Now coming to the next one, so we are going to be implement the word cloud. So word cloud means what? It's a visual representation of the text data where most frequent words appear larger and less frequent word appear smaller. Okay, so it is kind of a heat map. Okay, so guys here you can see the purpose of it. So see the most frequent word. So benefit help you understand what is the commonly talked in our data set. Spot noise in a data. Okay, compare two groups, right? So positive and negative, you can understand which one is coming, which is the larger one. Okay, which is coming more time. Now here is the pre-processing validation. So after the pre-processing guys, you can do the validation that what all words is coming how many times. Means you can just check one like the intensity, okay, of the given words and all using this word cloud. Now guys, how this word cloud look like, let me show you that as well. So what I will do, so here first I'm going to be take all the words, okay, from the data set itself. Now after taking all the words, I'm simply going to print that. Okay, so for that you will have to be like import this word cloud from the word cloud itself and then you can print that. See, this is the most frequent word. The larger word is the most frequent word and the smaller word is a basically it's not a very frequent word. Okay, with that you can take some overview on top of the data set and like even some point will be clarified with respect to the data and all. So over here guys, what I did, I'm doing the same thing for the like the different labels. Okay, label wise I'm doing a segregation. Negative is there, neutral is there, positive is there. Okay, and I'm going to be create a word cloud for each of them. So here guys you can see, so the word cloud for the negative tweets. Okay, so in the negative tweets, what all word is coming very frequently, what all word is not coming very frequently. Again it is for the neutral and again it is for the positive. So I hope guys you understood this data loading, you understood the data pre-processing, and you understood how to visualize the data. Now let's move to the next concept, that is going to be a custom data set. How to basically create a custom data set and how we can push it to the Hugging Face guys. So guys, if you want to be push any custom data through the Hugging Face, so for that, first of all, you will have to create a data or you will require a data. So here I created one dummy data, as you can see. So I have a data. Inside the data, I have a key. The key name is text and the next key name is label. So I'm going to be executed and let me show you the data, how it looks like. So this is the data guys. Now guys, what I'm doing, I'm going to be create a data frame of this data. So let me show you how the data frame looks like. So this is the data frame. So we have a text and the label of it. And what I'm doing, so I'm going to be convert this data frame into the data set, Hugging Face compatible data set. So Hugging Face is having one module, data set. So from the data set itself, I'm going to be called this from pandas. So and here I am passing my data frame. So once I will execute it, guys, I will be getting the Hugging Face compatible data set. So see, this is the data set where we have a 6 rows and the number of feature. So two number of feature, one is a text and the second is a label. So the similar kind of detail I was getting earlier when I was showing you the IMDb and the other data set and all. Now what I will do, guys, so here I am going to be check with the label, class label. What I'm doing, I'm going to be make a label as a class label. Okay, so guys, again, it is a compatible with the Hugging Face itself. When I'm going to be load it, I will be getting the label as a class label. Okay, so what I'm doing, I'm going to be execute it. So see, this is the optional step, you can skip it, but yeah, this was there in the like the documentation itself, and they were suggesting you can execute it, and you can name of the column as a means you can see here they have given you the description now, the name of the column to the cast. Okay, so list of all the column names, whatever is there, you can provide, and it will convert into the compatible mode, basically whatever mode the Hugging Face is required. Now over here you can see this is my final data set which I got, and in the data set itself we have a feature and the number of rows is 6. Now if I want to push this data to the Hugging Face, it is a very simple process. So either will have to be set this Hugging Face token as an environment variable, or if you are working with a notebook, directly you can log in to the to the notebook itself. So you need to call this notebook login, which I shown you earlier, right? So once you will run it, so it will ask you the token. Now which token you need to pass over here? So you need to pass the Hugging Face right token. Okay, so once you will pass the Hugging Face right token, you will get a permission. You will get a permission to write a data over the Hugging Face. Now over here you can check the detail, right? So you can call this who am I. So once you will call that, you will get the complete detail, right? So which like the basically service this token is providing, whether it's a read service or write service. Now apart from that, you will get like the other data as well, other metadata as well. So this will give you the complete detail in the specification. So here see, my name is a Sunny199. Here my full name is a Sunny Savita. This is my email ID. Now here email verified is true. So can pay false, I'm not paying anything. And here is the other metadata. Now AVAT avatar URL he is given to me, right? So there's my avatar. Maybe they have created some image and all as a profile image. Now here you can see access token. So yes, access token I have. Now here you can see, so role is showing read role. Okay, so see guys, why it is showing me a read role? See, if I'm going to be execute this one now, so in that case I will not be able to push my data, it will give me an error. See, the error is forbidden error. Okay, you require the right token. Now what is the issue over here, guys? So see what happened. So this is a by default token which Hugging Face is required, that is HF token. Okay, and this is the dummy token which I've created, HF token write and HF token read. So Hugging Face will not take this token, even though I'm going to be logging through the notebook, but somewhere in the cache Hugging Face is taking this token. Okay, maybe which is a read token. So what I can do, I can copy this token simply from here and I keep it over here. Okay, I can paste it over here, this particular token. Now after that, guys, I will have to do one more thing. I will have to restart it. So just go with the runtime and then restart the session. So once you will restart, guys, then only you can push it. So let me do one thing, let me restart. So we are going to be remove everything from the cache once we are going to restart it, and then we'll again we'll check the permission. And guys, what you can do manually also, you can assign that particular token as a HF token over here, okay, as an environment variable. So this is very important step. If you are not going to be follow that, maybe you will not be able to push your data. So better if you can check the details. Okay, now see, this is my data. I have converted into the data frame, and here is my data set, compatible data set. Now after that, what will happen? So here I'm going to be set as an environment variable. I'm going to be login also. So login wise, again, I'm going to be use the same one. So it is giving me any issue, any error. Let me check. Hugging Face token right. Okay, fine. So the spelling is a different one. I'm going to be use a different spelling over here. The spelling of mine token, Hugging Face token right. Okay, WRITE. Now this is fine. So yes, I'm able to set the token as HF token as well. Now if I want to log in, I can log in as well with the right permission token. So this is a token. I'm going to be copy from here. I'm going to be pass it, okay, inside the token. Now just do the login and then again check what permission you have now. So guys, once you will check the permission, if it is the right permission, then everything is perfect. So see, now you have a right permission, okay. So better guys, what you can do, you can set your environment variable, this HF token environment variable as a right token. Then only like you will be able to push your data. Now here what I'm doing, I'm just taking this dataset.push to hub. This is my repository. I can use some other repository because I was testing earlier. So this was my repository. So my custom data, this is the repository. Now if I'm going to be executed, so I will be able to push the data to the Hugging Face, okay. So it's going to be create a new repository. If you want to push it to the existing repository, that is also possible. So from here itself you can create a repository, and that in that particular repository you can push your data. Now if you will go and check with the Hugging Face, right, so just click on your username. So once you will click on your username, you will get the dataset repository, okay, under this dataset section. So the models is there. Now here is a dataset. So once you will open it guys, so see, this is the repository where you have pushed your data, okay, and you can see your file over here. The file name is what, data, okay. Now just open this data, and inside this dataset itself, see, this is the data, okay. It has so 1 minute ago they have pushed the data, and the data actually it is available in the Parquet format, okay. So you can change the format, you can keep in a different format. So those particular option is also available in the function itself, okay. That is not a big deal. Easily you can do that, easily you can configure that. You just need to hover your mouse over here, and you see you will be getting the different options, and you can check it out there. Now coming to the next part, that is going to be tokenization. So what is a tokenization guys? So tokenization means we are going to be convert, or we are going to be divide our data into the tokens, and we are going to be generate a token ID. That further the token ID will be passed to the embedding model. My embedding will be happen, my embedding will be performed, and then will pass that particular data to the transformer model, okay. So that is the entire sequence. So guys, with every sort of a transformer model, this tokenization will be this tokenization process will be associated. So let's see how we can perform this tokenization. So for that, first of all, we'll have to install the transformer library. So here I'm going to be install this transformer library. Now after that guys, what I'm doing, I'm going to be import the tokenizer. Now you can import any tokenizer. You can, there are so many models, okay. With respect to every model, you will find out their respective tokenizer. So we'll look into the different tokenizer in the upcoming session. I'll be showing you those particular tokenizer. But as of now, I'm going to be import this word-based tokenizer. Okay. Now see, this is a tokenizer. My tokenizer is getting loaded. So here I kept one example with respect to the tokenizer. I'll come to this example. I'll explain you this example. Okay. So as of now, you can look into the data set. I'm going to be take a same data set, means my previous data set itself, the custom data set, and I'm going to be tokenize this data set. Okay. So guys, before coming to this example, let me skip this example as of now, and let me explain you something from very basic, from very fundamental. So guys, I'm going to be skip it, and let's look into some other example. So see, this is the example guys. So here I already loaded this tokenizer. Let me show you this particular variable. What I will do, I'm just going to be take this tokenizer. So here you will see the object of it. So see, this is the object of the word tokenizer. Now what I'm doing, I'm just going to be call this tokenize on top of it, and here I'm passing my simple sentence, hello hugging face. So once I will pass it guys, so see, you will be able to find out the different tokens, okay, which was created from this particular sentence. Now what I'm doing, I'm just going to be pass another sentence. Let's see how it's going to be tokenize the sentence. So tokenizer dot tokenize, and here my sentence, hello how are you. Now let me execute it guys, and see over here, this is the token hello, and then comma how are you, and this is a question mark, right. Now not only the English sentence, we can tokenize any of the sentence. So here is one model. The model name is AI model from the AI for Bharat. Sorry, this is the repo name AI for Bharat, and this is the model name Indeed Bird. Now let me load this model. Let me load the tokenizer. Okay, this is not a model guys, it is a tokenizer with respect to that particular model. Okay, now here I have loaded the tokenizer. Now here I am giving my sentence, मुझे AI पसंद है. So with respect to this Hindi sentence also, I'll be getting a respective token. So see, it is able to create a respective token. So for converting the data into the token guys, you can directly utilize this transformer based model, and you can convert your data into the tokens. Okay. Now guys, if I want to convert this data into the token ID, see directly we cannot pass this token to the model. We'll have to be generate some ID with respect to this particular token. So let's do one thing. Let's try to generate a respective ID. Okay, the numerical ID with respect to the token. So here is my tokenizer, guys. So the tokenizer I am passing hello, how are you, and here my variable return tensor pt. Okay, so we are going to be written a PyTorch tensor, and see I will be getting an input over here. So let me run it and let me execute it, and see in the input variable in the input variable I am getting three things. The first thing is what? The first thing is the input IDs. Okay, the second thing is the token type IDs, and the third thing is the tensor. So let's try to understand one by one that what does it mean. Okay, what is the meaning of this input ID, token type ID, and this attention mask, whichever I need to pass where, whichever I need to pass to my model further. So we are talking about the input ID, guys. So input ID means this ID, these are the ID of the tokens from the model vocabulary. Okay. So the sentence "Hello, how are you?" get tokenized as a CLS. This is the starting token. This is the last token, and here is a sentence, right? Now, which correspond to this one. So 101, 102 is the specific ID for this separation and the CLS, and for rest of the rest of the word, this is the ID. Okay. So one vocabulary, the large vocabulary have been created. In that vocabulary, some number have been assigned to some specific word. Okay, so we are getting those number from this particular model. So hello, for the hello, this is the number. For how, this is the number. For r, this is the number. For you, this is the number. Or in whatever way it is going to be tokenized. So with respect to that particular word, you will be able to find out the number over here. Okay, so we are able to convert our sentence into the number. So this is my main sentence, my main tokens. Now token type ID, what does it mean? So the meaning of it, these are used in tasks like next sentence prediction. 0 means it's part of the first sentence. If there was a second part of the sentence, there would be a 1. Okay, so here you can see all the zeros are coming. Why? Because this is the entirely one sentence. Okay, so that's why all the zeros is coming. Then there is a attention mask. Attention mask means the token is a real or it's a padding. So with respect to the padding, see padding data we are not going to be consider while we are passing it to the transformer model for the real-time calculation and all. We will just consider the real-time token only. So for the padding, there will be attention mask which is going to be 0, and for the real token, the attention mask is going to be 1. Okay, so here you can see. So for all the tokens, the attention mask is 1 because as of now we don't have any sort of a padding. I hope this thing is clear. Now guys, let's do one thing. Let's look into the same example which I skipped just now. Okay, let's see what basically we are having over there, and then guys, your understanding will be more concrete. So here this is a proper like the example. So what I'm doing, guys, I'm going to be load the tokenizer as you have seen. Now after loading a tokenizer, guys, what I'm doing, so here I've created one function, the tokenize function. Here I'm going to be take one specific sentence. Okay, and I'm going to be written the tokenized value of it. So here will be my sentence. There will be a truncation. Truncation is going to be true. Okay, if the so what I'm going to be do, I'm going to be like truncate. Okay, truncate the text, right? And here padding, basically padding with respect to max length. So what does this truncation is showing? Okay, truncation is doing. So just try to read over here with respect to the truncation. They have given you the like complete detail. Separate token, pad token, CLS token, mask token, clean text, tokenization, strip, why this word piece prefix, right? So different variable is there. Let's look into the truncation. So constructive fast tokenizer, beat this tokenizer inherit from the period which contain the refer to the superclass of the information regarding the method. Okay. Okay guys, so I think I got to know what is the mean of this truncation over here. Truncation means basically it's going to be check, right, the specific length of the sentence. If the length is going to be more than that, let's say what I'm going to be check, there is my like one review. Okay, now the one review, basically there is a different length of the review. We have seen the word in the word count itself. So some of the review from 200 words, some of the review from the 250 words, some of the review from the 18 words. Now what I'm doing, I'm going to be to perform the padding. Okay, I'm going to perform the padding with respect to the max length. So over here you can see in the input, see if I'm going to be check with the first sentence, so there will be some input ID and rest of the thing is going to be padding. Okay, if this is going to be like this is going to be like basically like more than this particular length, okay, this input ID, so in that case it's going to be truncate. The sentence is going to be truncate. So that's why I mentioned the truncation is equal to true over here, right? Now, what I will do, see, if I'm going to be execute this one, and here is my first, here is my first sentence. Now, what I'm doing, I'm going to be pass this first sentence, okay, to the to this particular tokenizer. Now once I will pass it, guys, here you will get the details. So this is my tokenized input IDs. Rest of the thing is a padding one, okay, because it is checking the longest sentence over there. Then here is a token ID type. So token ID type is 0, means everything belong to the same sentence, and attention mask is a 0, okay. So wherever, whatever thing I want to be consider into the attention, self attention layer, this is a 1, rest of the thing is going to be 0 because it is a padding. Now if I want to be map the entire data, so what I'm doing, so see, this is my same function, and what I'm doing, I'm just taking this data set and I'm calling this map, and I'm passing this tokenize over here, okay. Batch is equal to true if the data set is very huge, so it will be able to encode the entire data. Now if I will check with the encode data set, so you will find out a text label. Now apart from that, you will find out the input IDs, token type IDs, and attention mask. And if you want to visualize any of them, you can simply check out over here. I hope, guys, this thing is getting pretty much clear to all of you. Now coming to the next part. So tokenization is clear, and basically how to perform the encoding, okay, the how to generate a token ID. This thing is also clear. Now not, let's look into one more example. So let's say if we have a lots of data. So here, guys, what I did, I took one sentence, and I'm going to be multiplied with a let's do one thing, guys. Let's try to multiply it with 1,000. So there will be 1,000 sentence, okay. So here my main aim to teach you how basically how to tokenize the large data set faster. So here is a code for the faster data set, sorry, for the faster tokenization. So let me keep it over here inside the new cell, and here is a code for the normal one. So what I mentioned in the faster one, so I just mentioned one parameter, use fast is equal to true, okay. Let's see how fast it is going to perform the tokenization. So as of now, I'm going to be take 1,000 sentence, it's the same sentence only, okay. You can take any other data set. So this is the text, this is my text, and here I'm going to be initialize the tokenizer, auto tokenizer from pre-train, and I'm using this parameter use fast. Now tokenizer text would be there, the data would be there, padding is equal to true, and truncation also is going to be true, okay. Now let me execute it, guys, and here let's try to calculate the time. So within 0.8 seconds, it's going to be perform the tokenization of all the data. Now here I'm going to be check with a normal one. So here I'm writing use fast is equal to false. Now if I'm going to be check, guys, so here you will see the time is around 1 second. Now let's increase the data set. Now instead of the 1,000 rows, I'm going to take 1 lakh rows, okay. Now let's see how fast it is going to be tokenized. So here you can see the tokenization wise, it is taking time. So it is taking around okay, 8 seconds. Within 8 seconds it is able to do. Now if you will check without fast, so guys, now you will feel the differences. So the differences basically it's going to be very huge. So in the fast mode it is going to be performed within 8 seconds, but now in the slow mode it will take around 1 minute. So here you will see the differences when the data set is going to be increased. So what this use fast tool is going to be do, okay. So see, around 17 seconds it took for 1 lakh rows. If you are going to be increase this rows, guys, it will take more time. Now, guys, what this use fast tool is doing. So if you will check with the use fast tool, so the backend, guys, it was implemented in a Rust. As you know, guys, Rust is a super fast language. The implementation of it is a super fast. If you have observed one package, UV package, that was also built on top of the Rust. Okay, one wrapper on the pip built in on top of the Rust, and which is a quite fast. So this use fast is equal to false. It is built in. It is using a built-in mechanism from the Python. But use fast is equal to true. It is using a mechanism from the Rust. Okay. So speed is very fast, and here it is a slower. Now library use tokenizer from Rust, and here the library use transformer from Python. So if you are going to be used, so see, memory use is slightly higher due to the Rust overhead, and memory uses is lower over here. So guys, whenever you are going to be mention this use fast or true and false, so automatically it's going to be adjust in a backend, and according to this all the thing is going to be implement, and because of this it is like a much faster. I hope, guys, you understood this thing. Now let's do one thing. Let's discuss how you can train your own tokenizer from scratch, and basically how you can load it after training it. Now, guys, the next thing is how you can train your own tokenizer. let's say if you have a data, now on top of the data, if you want to train your own tokenizer, uh, then how you can do it. So guys, for that there is a couple of algorithm. The most famous algorithm in Hugging Face, which is called BPE. Okay, the full form of the BPE is a byte pair encoding. So as of now, we are not going to understand that byte pair encoding in a like detail in a like in a mathematical way, but I'll give you the glimpse of it and how to utilize it in terms of the training of the encoding. Okay, we are just going to check with the practical as of now. Later on in some other video, I will show you the mathematical explanation and all of that particular algorithm, because it is not required, and if we are going to be like understand that, it will take again half an hour at least, and it might be a time consuming and could be a distraction from our practical. So here what I'm doing, see, I mentioned couple of things as you can see. So if you want to train your own basically custom tokenizer, so for that we are going to be use this byte of pair encoding algorithm with the Hugging Face fast tokenizer library. Okay, now what it does guys, if we're talking about this byte of pair encoding, so it create a token. Okay, it create a words, and from the word as well it's going to be create a sub word. Okay, so you can read out this definition. Byte pair encoding is a sub-word tokenization algorithm that helps break down words into the smaller pieces, making it specifically useful for handling rare word and unknown words in the NLP task. So guys, here you can see it is clearly state that this byte pair encoding is it's a sub-word tokenization algorithm. Okay, now, what does it mean, guys? So it is going to be help the like let's say we have any sort of a sentence. So this sentence we are going to be break into the word. Not only the word, guys. Again, it's going to be reiterate on top of this word, and it's going to be convert this word into the sub words. Okay, so that in a better way we can capture. So what we can do in a better way, guys, we can capture, right? We can capture the rare words and we can handle the unknown words in an NLP task. That's it, guys. So there is some certain mechanism behind it, like how it is doing. So that part we can understand later on. As of now, let's see how we can train our tokenizer from scratch. So for if I want to do it from scratch, so for that we have some corpus. So this is the corpus, guys, which I capped over here. So what I'm doing, so let me show you this corpus, this particular variable. Okay, so here, guys, in the variable itself, you will find out these three sentences. Now what I'm doing, guys, so here I'm going to be import this tokenizer from the tokenizers itself. Okay, this is the class. Now to this class, guys, I'm passing this models.bpe. So this models.bpe again I'm taking from here itself, right? So this model.bpe, it will provide me a byte pair encoding object. Now once I will execute it, so my tokenizer is ready. Okay, now what I will do, guys, so here is my tokenizer. So I'm going to be import one more thing, that is pre-tokenizer. Okay, now what this pre-tokenizer is doing, it's going to be remove all the white space and all, and it's going to be strip my data. So pre-tokenizer dot white space, I'm going to be initialize that, and I'm going to be assign it to the tokenizer itself, right? So here you can see we are going to be import this white spaces, and we are going to be assign it to the tokenizer back. Now what I'm doing, guys, so here is my trainer. So I have a trainer which I'm going to be import again from this tokenizer itself. Now here is my BPE trainer. To this one I'm going to be initialize my vocabulary size. You can pass any vocabulary number over here. I'm passing it 100 as of now. Okay, so in my vocabulary there will be 100 tokens. So because I have a small data set, that's why. So my trainer is ready. Now what I will do, guys, see, my trainer is ready, and after that I'll call this trainer on top of my data set. So I have my corpus, means I have my data set. Now here is my trainer. Everything is ready, guys. Now what I will do, I am going to be train it. So I took this tokenizer. See, this is a tokenizer. From this tokenizer, I'm going to be called this train from iterator. Okay, and I'm passing my corpus over here, and then there is a trainer, right? That's it, nothing else. So once I will do it, guys, I will be able to train my own tokenizer. The data set is very small, so it will not take much time. Let me revise this flow. So first we have a data, then guys, after that we have a tokenizer. We are going to be create a tokenizer using this BPE. Okay, then guys, we are going to be assign some external parameter to this tokenizer itself. Then we have imported this trainer, okay, with the vocabulary size. Now we are going to be combine all the thing. So tokenizer dot train from iterator, and here is my corpus, and here is my trainer. That's it. Now let me save this tokenizer. So once I will run it, guys, so here I will be getting my custom tokenizer. See, this is the tokenizer, guys. In the JSON file, as a JSON file, I am getting my tokenizer. So it will take some time and it will be visible over here. So let me again refresh it. So guys, it is getting refreshed. We'll be getting the tokenizer over here, right? So now guys, after that, so see guys, this is my tokenizer, custom underscore tokenizer.json. Now if I want to be load this tokenizer, so how I can do that? So for that guys, I will have to be import the pre-trained tokenize faster. Okay. To this pre-trained tokenize fast, I'm going to be pass my JSON file and I'm going to be pass some other token. Okay, so unknown token, pad token, CLS token, separate token, mask token. So for the specific token, I am going to be pass the token detail. Like if there is a unknown token, it will be classified with this particular level. If it is a padding token, it will be classified this pad. If it is a CLS token, it's going to be classified with that. Okay, something like that. So I'm going to be handle all the tokenization. See, I have a data. This data will be converted into the tokens. But if any rare word is coming over there, let's say anything with respect to the padding, anything which is like not inside the vocabulary in this vocabulary, so that particular word will be like marked as unknown word. If any padding is there, then pad. If any classification and separation token means is starting from, which is coming at the first place or which is coming at the end in the but actually specifically it happens. That's why we have added this token. Otherwise this unknown and pad is a universal token, means unknown for the unknown word which is not there in a vocabulary, and padding basically for the padding one. Okay, I hope you understood. Now see guys, my tokenizer is ready, this HF tokenizer. And now what I'm going to do, I'm going to be save it finally. Okay, so here is my final tokenizer which you will get inside this particular folder. So in the my tokenizer, guys, see my tokenizer HF, I am able to get my tokenizer, my own tokenizer. I hope it is clear to all of you and you are able to understand the entire process of creating a tokenizer, even like with the handling of the different other levels, right? Whatever is there. Just try to remember this two, unknown and the pad, which is very much important. Now guys, let's do one thing. Let's start with the embedding. So guys, we understood about the tokenizer. We have seen the different concepts related to that. Now let's understand after tokenizing the data, what we can do next. So first guys, what I'm doing here, I'm going to be load a model. So here is my tokenizer. I'm going to use the bird base case tokenizer. Okay. So this is the model actually, and using this tokenizer dot from pre-trained model, we are going to be load a model specific tokenizer. Okay, so every model is having their own tokenizer, like we have trained our own tokenizer, the custom one just now. Similar to that, every model have been trained their own separate tokenizer. Okay, for what? For their for capturing their vocabularies, because every model have been trained on some data set, right? And every data set is having their own vocabulary. So with respect to that vocabulary, this tokenizer have been trained. Now guys, what I'm doing, so here I'm going to be load this tokenizer. Now what I will do, so here is my input. Now what I'm doing, so I'm going to be load my model as well. So I'm using this automodel class. So from this automodel dot pre-train, automodel dot from pre-train, I'm going to load this bird base encased model. Okay, so my model is getting loaded. Now let me show you how the model will look like. It is a bird model. So after loading this model, I'll be able to get each and every detail of it. Now guys, what I will do, I'll pass this particular input to the model. Okay, and what I will do, I'll try to generate the output of it. So guys, see, this is the model. So my model name is what? My model name is a BERT model. Okay, and here in the BERT is nothing. BERT is a implementation of the transformer encoder itself. And in a BERT, we have 12 encoder. We have a 12 encoder stack. So this each and everything I clarify in my previous videos. If you don't know about it, you can go and check. Now guys, here we have a BERT model. In a BERT model, we have a 12 stack of the encoder. Now guys, see, we are going to be load this BERT model using this auto model class. Now we have a different other classes. I'll come to that. Okay, and okay, first let me show you those particular classes, then I will come over here that what I'm trying to do. So guys, if you will go and check with the Hugging Face, you will find out a different auto model classes. So I kept a list of those automodel classes, and with that, your understanding will be clear. So see, automodel, the task of this automodel class is just to load a base model. So we use this automodel class so just to get a embedding. Okay, there is no head, no additional head for doing any task like classification or for sentence prediction, question answering, and all. Okay, so this auto model class is just going to be load a base model like we are loading the BERT model. We have other classes. So auto model for mask LM. Mask like LM is for the mask language modeling, which is a core task of the BERT model. So if we are going to be use this particular class, if we are going to be use this particular class auto model for mask LM, in that case, on top of the normal model, we are going to be append the head, okay, at the end of the model, and that model will be responsible for predicting the masking word, okay, whatever masking words are there. Now sequence classification, so text classification, for the text classification we're going to use this class, right? So I can explain you this thing whatever I'm saying over here. So I can explain you over the blackboard itself. Maybe with that the understanding will be more clear. So you can assume, let's say we have a transformer. Okay, so you can think this is my transformer. Now this transformer is taking an input, as we know, right? So how it is taking an input in the previous class itself, I explained you that. So we have a words, sorry, we have a sentence. Let's say my sentence is, my name is Sunny. Okay, my name is Sunny. So this is my input which I need to pass to the model. Now what my model will do, so for before the model itself, let's say this is my transformer model, okay, encoder part of the transformer model. So here I can write encoder part of transformer model. Okay, now guys, what will happen, see, this particular sentence will be divided into the multiple tokens. So here one token is my, let's say here is my, the second token is going to be, let's say, name, the third token is going to be is, and the fourth token is going to be Sunny. Now further this token will be converted into the ID, token ID. Token ID will be assigned using the tokenizer, using the tokenizer. Okay, so further IDs will be assigned to that to this particular token. Let's say some number is there to this particular word. Let's say 1 2 3 4, to this one 5 6 7 8, now 9 10 1, or 0 1 2 4. So this is the ID, the token ID. Now from where this ID is coming, so whenever we were training any sort of a model, let's assume this is a transformer model which was trained on a huge amount of data, huge amount of data. Okay, so with respect to the data, one vocabulary have been created. One vocabulary have been created. Now, what is a vocabulary? Vocabulary is nothing. It's a collection of words. Okay, so it's a collection of words. Now, to this collection of word, guys, we have a different words, and every word is associated one numerical value. Every word is associated with one numerical value. So this numerical value itself is called the token ID with respect to every word. Okay, and this tokenizer, see, tokenizer is doing the same thing. It is going to be mapped the word according to their respective token number with respect to any specified model. So every model is training their own tokenizer on top of the vocabulary, and whenever we are passing any sentence, so first it is going to be converted into the token, and then it is going to be assigned one specific ID to that. Now what will happen, so after this one, guys, uh, after assigning guys this ID and all, so this will come to the word embedding. Okay, so word embedding, and the embedding will be created with respect to every word. Okay, embedding would be created with respect to every word. Then what will happen, guys, so let me highlight over here this thing. Then what will happen, see, this particular thing, this input, guys, this input, basically whatever I have designed over here, this particular input is going to the model, is going into the model. So let me design the model over here. So this is going to be my model. This is my transformer model. Okay, I hope you understood the thing very clearly over here. Now what will happen, guys, see, this transformer model is having two things. This transformer model is having two things. First is called the self attention, and the second is called the feed forward neural network. The second is called feed forward neural network. Feed forward neural network. Now guys, see, whenever this data will go, see, one more layer would be there before passing the data to the transformer self attention. The layer is going to be a positional encoding. Positional encoding. So I would be having positional encoding, and my data is going through this positional encoding layer. So the sequence is going to be preserved of the data, and then it will go to the self attention, and then finally it will go to the feed forward neural network layer. Okay. Now with that, what we are able to do, we are able to generate some sort of a embedding at the end. So we are able to generate some sort of a embedding at the end. Okay. The final embedding I'll be getting over here. Final embedding I'll be getting. Now guys, see, this is my embedding. Okay. Now if you're talking about the transformer architecture, so there is a two part of the transformer architecture. So transformer is having two sections. The first section of the transformer architecture is called the encoder, as we know, and the second part of the transformer architecture is a decoder. So if we're talking about, let's say, like the encoder, so BERT model is an encoder based architecture, whereas this GPT is a decoder based architecture. So whatever model you can see, like GPT 3.5, GPT 4, 4.0, okay, even Mistral and Llama model, Mistral and Llama, whatever model basically are prone to text generation, those model actually it's a decoder based model. And encoder based model is also available. So encoder based model like BERT is there. Okay, couple of more model. I think BART is also encoder based model. I'm not sure. You can cross check. T5 is not encoder based model. It is an encoder and decoder based both based model. Okay, so BERT. I can take example of the BERT, right? So what we are getting, guys, we are getting the embedding. Now see. So this particular embedding, let's say we are going to be implement a BERT. Okay, now this BERT basically we're talking about the BERT. So this BERT we can use for the different tasks. So we can use this BERT for the text classification, right? We can use this BERT for the question answering, as we know, right? Question answering. We can use this BERT for the let's say for the summarization. Okay, summarization. So guys, see, whatever thing I told you so far, this one. So this all the thing from here to here, right? So this entire thing from here to here means after converting this thing into the positional encoding and all. So we are going to be implement using the auto model only. Using the auto model, we are just getting an embedding, this particular embedding. Okay. Now on top of that, on top of the model, what we can do, we can apply the head. Okay. So this is my model. Let's say I'm going to be apply head. I'm going to be append one more layer over here. So let's say here I'm going to be append one more layer, and this layer is going to be, let me design that particular layer. So this layer is going to be, this layer is going to be, it's going to be for the classification. Okay, classification. So what would be there for the classification? So for the classification, again, see, the linear projection will be there, linear projection will be there, as well as the softmax will be there. Okay, softmax will be there. Okay, so this is the head which we have appended over here. Now this head basically, see, along with this model, okay, this model transformer, like where we are getting this embedding and all, and this head, right? This head basically for what? For the classification. Okay, sequence classification, text classification, auto sequence classification. So for this one specific class have been implemented, that is called auto text classification, the class with auto sequence classification, right, in the Hugging Face. So the class name is what? Auto sequence classification. Now let's say what I have to do, I have to like predict the question, I have to predict the answer of the respective question. So for that there will be a different head. Okay, there will be a different head. Different head means what? Like we will not be having basically this we will be having a softmax. Softmax will be a part of every like head. Okay, and the linear projection ever also. But we are going to do a prediction at the end, means we have done the training and we are going to do a prediction in such a way that we are getting a specific sentence instead of one single word, right? So guys, over here what I wanted to say, so see, I had a data. The data basically, see, till here it's all about the tokenization, this ID, then there is an embedding, word embedding, then positional encoding, then this is the transformer, main component of the transformer. Now after processing the data from this particular transformer model, I'm getting an embedding over here, right? So we have an embedding. Now guys, this embedding, right? So this whatever embedding we got over here with respect to this model, this itself is called the sentence embedding. Means we are going to be convert our sentence into the embedding and we can consume this particular embedding. Okay, so whatever model you can look into the sentence transformer and all, right? So over there what we are getting this embedding itself, right, after passing it from the self attention and the feed forward. Now on top of it, if I want to do any sort of a prediction, means after the training, if you want to do the any sort of a prediction, so there will be a specific head. I'm talking with respect to the Hugging Face. Okay, the whatever classes, specific classes have been provided by the Hugging Face. Okay, different classes have been provided by the Hugging Face. Different auto classes have been provided by the Hugging Face. So this auto model class, using this auto model class, we are just getting the embedding. Okay, but guys, if we are talking about, if we are using any specific class, so that specific class have been designed for some specific task. Let's say auto sequence classification for doing the text classification, auto LM, okay, for language modeling, means we are going to either we are going to predict the masking word or the next word, question answering for performing the question answering, right? And at the end of the model, one specific head have been appended so that we can get a desired output. Okay, now I hope this entire thing is clear. If you're not able to understand, guys, just try to recap this entire thing. See, this is the like entire like explanation from my end. Now let's do one thing. Let's try to check with the practical. So what is happening in the practical? See, we have a auto model class. This auto model class is just generating an embedding. There is no head, no extra head. Okay, after the self attention and the feed forward neural network, we are just getting a like the numerical representation of the data. Then mask LM, basically it is for the it is for predicting the mask word. Then sequence classification, auto model for sequence classification for predict the sentiment and all. Then token classification, again to check with the NER, POS tagging and all. Auto model for multiple choice, so MCQ, for the MCQ there is a specific class. Auto model for next sentence prediction, there is a specific class for that. Auto model for causal LM, right? So this using this class auto model for causal LM, we are going to be load all the GPT style model, means we are going to be we are going to be load all the decoder based model. So but this one GPT or Llama, Mistral, DeepSeek, okay, whatever like model is there, the which is responsible for doing the text generation. So every sort of a model we are going to be load using this particular class. Then the other classes is also there for the specific task. You can read about it. Now this auto model for causal LLM, this particular class we are going to be used further as well, so that like we can so that guys we can load any sort of a LLM model and we can do the fine tuning and the inferencing on top of it. Okay, I hope you understood the use of these particular classes. Now what I'm doing, guys, so here what I did, I just loaded the model. So let me show you where is my model. Okay, each and everything I'm going to be clarify over here. So see, this is my model. Now in the model, guys, this is the bird model. Okay, now what I'm doing, I'm passing my input to this bird model. Now once I will pass the input to this bird model, so here you can see this model actually it is without head. Okay, so we are going to be load this particular model where it is, here it is. So we are going to be load this particular model using the auto model class. So till where I will be getting my output, if we are going to be use this auto model class, so I will be getting an output after this feed forward network. Okay, after this self attention and the feed forward, so we will be just getting a simple embedding of my data, right? So what I have this auto model from pre-train. Here is my model, and see I'm able to load the model. Now with this particular model, I will not be getting like any classification, question generation, or I will not be able to do any language modeling and all. I will be simply getting the output of the self attention block, self attention, and the output from the feed forward neural network. Okay, so here guys, I'm passing an input. So once I will passing the input to this one, so see after passing the input, I'm getting an output. Now this is my output, guys, which I'm getting. This is the embedding version of the sentence, which is getting processed from the which is getting processed from the this bird model itself. Okay, now after that, see, if we want to take a embedding, the sentence embedding from there, so first of all we'll have to check a shape of it. So if I'm going to be print the shape of this last hidden state, so what is the last hidden state? I'll come to that. I'll try to explain you this part as well. So guys, the shape of it is 1, 8 and 768. Now 1 means what? So it is representing to the 1 is a complete sentence. There is a 8 token inside the sentence, and each token is having a dimension of 768. Okay, If I'm going to be collect zeroth from this last hidden state, so here you can see this is the last hidden state where we have a 8 token, and each token is being represented by this 768 dimension. Okay, now guys, if I will print this output dot last hidden state 00 means I'm able to get the first sentence. Okay, and here you can see the length of this particular sentence, which is 768 dimension. Now if you will check with the model specification also, when I was loading the model, so the model also this thing have been mentioned. Does the linear feature means the final layer, okay, final output block of that of this word encoder, it is providing you the 768 feature of embedding, okay, with respect to every token. Now guys, here you can see this is representing to my entire sentence. This particular one is representing to my entire sentence. Okay, where guys, not this one, this is representing to my entire sentence, this one, this particular line. Okay, now what I'm doing here, I'm going to be check with the second token. So see, this is the second token. Now what I'm doing guys, I'm going to be check. Okay, so what I'm doing, I'm taking output like last hidden state, and I'm going to take a mean of all the dimension. Okay, so every token is having the dimension 768, and I'm going to take a mean of it. So here I'm checking a length, right? And guys, here you can see this particular vector. Now this particular vector actually it is representing to a sentence as an embedding. So this itself is called a sentence embedding. Now what I have done over here, so I have all the words. Okay, the words are basically in terms of token. I'm taking a mean of it. Okay, there is a like couple of popular methods. So we can take a mean, or we can take a max of every sentence, or every word. Okay, means every word is being represented as a 768 dimension feature, right? So what we can do, we can take a maximum value of each of the like word representation, and we can combine them, and we can showcase as a vector. But this is a very popular way what we are doing. So we have an output, we have a last hidden state. From there we are going to be collect all the token, means the embedding of all the tokens. We have 8 tokens, and then guys, we are taking a mean, and here guys, you can see this is the length of that, means final 768 only, and this is a representation, the vector representation. So in short, I can say this is nothing, this is my sentence embedding. Whatever sentence, hello, how are you, I have passed, it is a vector representation of it. So whenever we are going to be convert any sentence into the vector, so in the backend the same thing is happening. I'll show you this particular thing using the sentence transformer based model. Okay, now guys, what I'm doing, see, we are talking about the last hidden state. So this last hidden state, it is not representing to that neural network state. Okay, it last hidden state means, so whenever we're talking about the board guys, so in the board we have a 12 block. Okay, so we have see, if you don't know about this block, means in the one block itself we have a cell potential as well as the feed forward neural network. So similar to that, we have a 12 block in bird small model, right? So this all the block is identical, means every in every block same kind of process is going to be happen, right? And here whatever we are getting from the last block, that will be my embedding. So if we are saying this last hidden state, so last hidden state means what, we are going to be generate a output from this last block, okay, from the final block. So you can see with this line diagram, so we have a multi-head attention. We are in the multi-head attention, see, after the multi-head attention, we are passing the input from the add and norm, then we are passing it to feed forward network, and then add norm. So in the last hidden state, this entire processing is happening. Not only in the last hidden state, in every block this entire processing is happening. Now in the last block as well, this entire thing is going on. First we have a multi-head attention, then add and norm, then feed forward network, then add and norm. Now whatever output we are going to be generate from here, that is going to be my embedding. I hope you understood it very well. Now what I'm doing guys, so I'm going to be check. Okay, so let's do one thing, let's try to perform one small practical. I have this cosine similarity method, right? So I'm going to be import this cosine similarity method, and see, this is my first sentence, hello, how are you. This is the next sentence, hi, how do you do. Okay, so what I'm doing, I'm just going to be perform the tokenization first. Now after the tokenization guys, see, here I'm saying toss no grade. No grade means training is not required. I simply doing a prediction, means I simply getting output without any sort of a training. So whatever pre-trained weights are there, I'm just taking those pre-trained weights, and using those pre-trained weights we are going to be convert into the embedding, and that but we are going to be stored into the output. We are not doing any sort of a training over here. So we have a model guys, to the model we are passing input, and from here we are getting a final vector. Okay, the like the sentence vector. Now this our sentence vector, this output 1 and output 2, we are passing to this cosine similarity method, and here we are checking the similarity between the sentence. So there is a 88% similarity between these two sentences. So I have a sentence, now the sentence is being converted into the sentence embedding using this bird based model, and using that particular model we are able to check the similarity score between the two vector. Okay, now guys, for this particular task, one specific library has been introduced in a Hugging Face. That particular library is called the sentence transformer. Okay, so here is the link of it. I have appended the link of the sentence transformer over here. Now let me open it and let me show you that what all model is available over here. So once I will scroll down, and after scrolling down guys, I'll be getting all the models. So there is in total 126 models. Okay, so you can see all the model name. This all the model, basically it's a transformer based model, and whatever mechanism I have shown you over here means first we are going to be load the model. After loading a model guys, what we are doing, we have a sentences, we are doing a tokenization. Now what we are doing, we are getting an output from the model, and we are getting an output from the last state. Okay, we are not doing any classification, we are not doing any sort of a generation, we are simply getting a output from the last hidden state, means from the last block of the transformer based model, that is BERT in my case. So that particular embedding we are going to be collect over here. This is nothing, this is a sentence embedding with respect to the given sentences. Okay, we are able to convert our sentences into the embedded version, and then we are able to find out a similarity score out of it. Now guys, over here if you will look into the sentence transformer, so in the sentence transformer guys, there is a so different model, and this all the model basically it is based on the transformer itself, and the same kind of mechanism is going on over here. Okay, so let's do one thing guys, let's try to take any one model and let's try to perform the practical out of that particular model. I hope guys, this all the model is visible to all of you. I hope I am not blocking the way of this particular model. uh, See, you can read out the name of it. Most of the model is based on the transform based only, and yes, we are getting a embedding out of this particular model. So first what I'm doing, see, first of all I will have to be install this sentence transformer. So let me install the sentence transformer. It will take some time in your system, like if you are going to be installed it first time, and then after that I will have to be import this sentence transformer. Okay, now after installing the sentence transformer, I'm going to be take any one model from there. So I'm going to be take this all mini LM L6 V2, right? So this particular model I am going to be use, and after loading this model, I will do the same thing. I will convert my sentence into the encoding, into the embedding, and then from this embedding I can simply check out with the similarity. Okay, so let this model load. Sorry, let this let it download. Okay, and after that what I will show you how basically you can get a similarity, the dimension and all everything we're gonna check over here. Okay guys, so my model sorry my package is getting installed, and now see, after installing it, it will ask you to restart the session. So please restart the session so that you will get the updated version of the sentence transformer. Now after that guys, see, I'm going to be import this particular package, the sentence transformer. Okay, and after that guys, you can see over here I'm going to be load my model as well. So my model name is what, all mini LM L6 V2, right? So my model is getting loaded, and after the loading guys, what I will do, I'll try to encode the sentence. I have a two sentence, sentence first and sentence two. So let me import that also. Just a second, I am checking with the sentence. See, this is the sentence. Okay, so sentence are here, cosine similarity is there. Okay, this is fine. Now what I will do guys, see, the sentence transformer is providing you their own encoding method, means you can call this encoding method automatically, the tokenizer and all everything will be there. So first what I'm doing, I'm going to be perform the encoding. So I pass the first sentence, and see, here is my embedding one. So this is called a sentence embedding guys. We are going to be convert sentence into the embedding, and the same kind of mechanism is happening over here. Means first my input will be passed through the transformer model, and then through the transformer model, whatever we will be getting after the cell potential layer and the feed forward layer, those particular tokens we are going to be combined as an embedding. Okay, and that will be the answer of my sentence, means that will be the final answer, final embedded version of my sentence. That is only called the sentence embedding. Okay, now here is what, here is my embedding guys. You can check it out, you can check out the length of it. So what is the length of this particular embedding? You can simply take this embedding, and what you can do, you can print the length of it. So just write the length, and here pass this embedding. So see, you will get the length is 384. Okay, so we were getting the length of the our sentence length was the 3768. Okay, because word has been trained in such a way that the size of every word, the representation of every token at the end of the self-rotation it is 768. Okay, no need to worry guys. See, whenever we are passing a token sentence to the transformer model, everything is happening in the parallel itself, okay, in a backend. There is a matrix multiplication is going on in the entire calculation and all. So even though the word is being represented, the every word is being represented as an embedding that is passed as a single matrix, okay, for the calculation and all. Now over here you can see this is the representation of my entire sentence. This is a like sentence embedding, and the size of it is 384 because my model length is small. It is a small LM model. Okay. Now it's a mini small model, right? So here if I'm going to be check out with the second one also, so I'll be getting the embedding of the second one as well. So I can simply check out with the embedding, and I can simply check out the embedding over here. See, this is the embedding of the second sentence, right? Now what I'm doing guys, I'm just going to be check the similarity score. Even though I already executed this, but let me show you. So the similarity score I'm getting 51%. Okay, so earlier I was getting some good accuracy, and here I'm getting the 51% similarity between what, between these two sentences. Earlier I was getting more than 80% of similarity. Why? Because we were capturing the more feature from the sentence. The dimension was high, 768. We were able to capture the more feature, and because of that we were able to get the good similarity between the sentence. Now here my sentence, my model having a small dimension, and we are not able to capture much context from the sentence, and because of that we are not able to capture much similarity. So guys, like the small model are faster, that is true, but guys, if we're talking about the reliability, where you can rely, so you can check out with the large model. They are that going to be decode your sentence into the multiple features, okay, and you will be getting the better exposure of a sentence, and you can even get the good similarity score as well, right? Even though it depends on the context of the sentence, but again I'm saying, see, I'm just like giving you the suggestion that you can use some high dimension model which will capture the more context of your sentences, right? Now what I'm doing guys, see, here I shown you the different classes. So auto model classes without any head, it is just giving the embedding. Now there is a different head, okay, it is for what? It is for the specific task like mass language modeling, sequence classification, token classification and all. I hope guys you understood this thing very well, but until and unless we are not going to check with this one example, I think this is not going to be complete. So what I'm doing guys, so here I'm going to take one sentence, okay, and here I'm going to be tokenize it, right? So tokenization is there. Now it is saying tokenizer is not defined. So I think I haven't loaded a tokenizer. So first let me load the tokenizer over here. I'm going to be load the same tokenizer, the bird based tokenizer. So here itself I have imported that in a previous like solution itself. So let me load it again over here. Okay, give me a moment, I'm just loading that. So tokenizer, where is the tokenizer? Here is my tokenizer. Just a second guys, model is here. Yeah, this is my tokenizer. Okay, perfect. So tokenizer is here. Now after that, what is required? Let me tokenize this thing. So sentence, yeah, this is fine. Now here in the input guys, what I will get, I'll be getting uh if you will check with the input guys, so we have a different like values. So first is the input IDs, then we have a token type, then we have attention mask. Now what I'm going to do guys, from this input we are going to be remove this token type ID. It is not required for simple classification, okay, because in the simple classification we are not going to predict the next sentence or next word. It is a simple one word classification. So here is my input which we are going to be passed to this auto sequence classification. So I'm going to be load this auto sequence classification, and from here we are going to be load this model distill word uncased fine tune SST2 English model, okay. So this particular model I'm going to be load. Now after loading this model, this is my classification model, I'll pass my input to this one, okay. Now guys, over here you can see this model is this class is specifically for load this word based model or distill word based model along with the classification head, okay. So if it is a classification head, then at the end of the model, along with the embedding, see, along with the embedding means on top of the embedding, there will be one specific head which is going to be predict the probability of the words. Okay. So yes, my model is getting loaded. Here you can see it is a very small model. Now to this particular model, I am going to be pass my input and it is going to predict what basically I will be getting as a output. So from the output, guys, I'm going to be check out with the probability. So output.logits. It is not only giving me the embedding. On top of it, there is a specific head which is going to be predict the probability. Okay. Now it is saying torch is not defined. So simply I can do one thing. I can import the torch over here. So import torch. Now what I will do, see, after importing a torch, I can like see it is able to give me the output. Now I'm going to be check the logits, mean the probability value, okay, of every sort of a word. Now here is my like the max word, argmax means the highest probability word. I'm going to be fetch from here whether it is a positive or negative. Now once I'm going to be check out with that, so see, this is the final output. So 1 means positive and 0 means negative. So it is going to predict this pre-trained model is going to predict. I'm writing over here, I am doing very happy. Okay, so this is my sentence, and here is a classification of this sentence. It is saying it is a negative sentence, right? So maybe the model is not good, because of that it is not giving me a correct answer. But yeah, at the end you are getting an answer, that is fine. But what we can do, we can use some good model to get out a correct answer. Now similar to that, guys, what I did, I have used the GPT model just to do the like the further generation and all. So I'm going to be use the GPT tokenizer to convert this GPT data, whatever data will provide to the like the for the inferencing and all into the tokens, and that particular tokens, that particular data again will go to the model. This is my model, guys, GPT model. And this GPT model mainly for the next word prediction, mainly for the generation, text generation. Okay, nowadays we are using a updated GPT version, updated GPT models like GPT 3.5 turbo 4 and all. So the model is getting loaded over here, guys. Now what I will do, I'll be giving my sentence, the transformer are best. Okay, then I'm passing this sentence to this GPT model. Okay, first I'm going to do the tokenization. Now after the tokenization, guys, here is my GPT model, GPT model dot generate. So here is my input ID, here is the max length. Okay, so predict next 5 token. Here I'm passing that do sample, I'm saying file. I want a deterministic output. Okay, so yes, once I will run it, guys, so here I'm writing with no grade. So I'm not doing any sort of a training, I'm just doing an inferencing after loading the model. So see, guys, the attention mask is not set, can no be deferred. So what I'm getting, guys, see, if you will check, so I'm getting an output into the GPT output into this particular variable. Okay, now what I will do, I'll be showing you the GPT output. I'm just going to be decode it over here. So yes, I'm going to be decode, and this is going to be my final answer. So transformer are bestly creature that can be. So this is the final generation, which is a very poor compared to the today's model. So this, guys, all the thing which I'm showing you now, it is like it is not a latest one. It was being used like 4 to 5 year back. Okay, so nowadays we have a good model, the GPT based model, which we can directly load using the same class, this auto for causal LLM, and that I will show you in the upcoming session. Now, guys, there is one more thing. There is one more class. The class name is a auto config. So this auto config, basically what it is doing, it is going to be load the configuration of any sort of a model. Okay, so what I'm doing, I'm just going to be import it, and here what I'm doing, I'm going to be load this particular model. So I will not be get a model over here, I will be getting the configuration of this model. So configuration wise, I will be getting like what is the hidden size of this model, what is the number of attention head is there, what is the vocabulary size, okay, which was used to train this model, then hidden act is there, number of label is there. So this all the detail I will be getting with respect to this particular model. And now once I will print it, so see, you will get a number. So the hidden state size is 768. I think I already shown you with this particular model when I created an embedding. Then here is the attention number of head is 12. Then here is a vocabulary size, so 30,522 unique words are there, while this model was trained on some data set. Okay, this was the number of vocabulary, this was the number of tokens. Then gelu is a hidden act activation function, that there is a number of label, two number of label. Okay, now, guys, if I want to do any configuration change, let's say I don't want to be like use this model for the binary class, I want to be use this model for the multi-class. So simply I will assign this config.num label, and I will assign 5 over here. Now once I will write it down, so guys, now if I will check, okay, now if I will check, if I'm going to be print, if I'm going to be print the configuration, see configuration number of labels. So here you will get the 5 because I configure the 5 over here. So here if I'm going to be printed, now see you are getting the 5 over here. So what I can do, I can use this auto model class, and from this configuration now I can load my model. So here guys you can see my model is getting loaded, and now this model basically along with this 5 classes, okay, means whatever model I have loaded over here, it is having a 5 classes, means we can predict the 5 classes instead of this by default 2. So what this auto config class is doing, it is just going to be load the config, and using after loading the config and all, see we can make a changes into the configuration, and with that updated configuration we can load the model. As simple as that guys. Okay, I hope this entire thing is clear. Now guys, we'll see how we can load the model in our local machine using this Hugging Face, how we can take the model on our local server. Guys, if we want to download any model from the Hugging Face hub on our local system, so we can do it using the Hugging Face hub. Okay, so Hugging Face hub is having a special method. The method name is snapshot download. Now to this snapshot download, what we have to pass. So here we have to pass couple of parameter, which is a mandatory one. So first you will have to pass the repo ID, where which model you want to download. The second thing is where you want to download the directory, and here the next one, local directory use sim links. Okay, so to copy instead of the system link, it's a system linking. You can like as of now ignore this one. You just need to be focused on this two. First is the repo ID and the second is the local dir. So what I'm doing, I'm just going to be create one folder over here. My folder name is going to be test. Okay, so here I'm writing test. Now guys, what I will do, see after creating a folder, so here is my folder, the folder name is test. Now I am going to be executed is snapshot underscore download. So this snapshot underscore download, it will download the model in a specific folder, and then I can use this particular model anywhere. Okay, so see my model is getting downloaded. It will take some time. The size of the model is 532 MB. And here what I'm doing guys, see I'm going to be load a model, means I can simply load the model, the same model. What I'm doing for that, I'm going to be like import this auto tokenizer and this auto model class. So from auto tokenizer dot from pre-train, I'm going to be load the tokenizer from the same folder. Whenever we are going to be like download any model now, so along with the model guys, we will be getting their own tokenizer as well. So everything would be here, tokenizer model and all everything. So no need to worry that you will have to be install the tokenizer separately or what. So no, tokenizer will also come over here. Now guys, see the model is getting downloaded over here, and after that what we'll do, we are going to be use the auto model tokenizer and this auto model class. We are passing our location like over here wherever we have downloaded the model, and then guys here this is the location basically of the model, and first we are going to be import the load the tokenizer, and then guys we are going to be load the actual model. So let it load, it will take some time, and let it complete because the download process will take some time. Okay, the model is a little huge. So as you can see guys, we are able to load the model, we are able to download the model, and this model on our local system. Okay, this model in our local disk, here you can see the complete folder. Even you can download it inside your own system, that is also possible, or you can keep it at any server. Now after this one guys, let me show you where we have loaded that. So see, this is the class which I shown you. Here is a tokenizer. So first let me print the tokenizer. What I'm doing, I'm going to be create a new cell, and in the new cell I am going to take this variable and I'm passing it over here. So tokenizer is here. See, we are able to do that. Now here I can show you the model as well. So we are able to load the model. Now I can utilize it in the same way like I was using earlier. So earlier guys, using this auto model classes and this auto sequence classifier class, auto causal LM class, we were loading the model in memory. So if we are going to be destroy the memory, the model will going to be removed. But guys, over here now this time we are going to be we are going to be download the model in our own system. and then we are going to be load that particular model in memory. So the model is not directly loading in memory from the Hugging Face hub. Instead of that, first we are going to be download the model, a snapshot of the model in our local system, and then only we are going to be loaded. So this is a major difference. So if you are looking to download any model, you can simply use this particular method and you can keep the model on your own server. Now coming to the next part. So whenever we're talking about the Hugging Face, guys, so Hugging Face provide as a different method. So in order to those method, there is one more popular method that is called pipeline. So pipeline is providing you, this pipeline method is providing you all this parameter like task, model, tokenizer, config, framework, device, revision, and the other parameter. You can configure this parameter and according to your requirement, you can load the model. Okay. So first let me show you with the pipeline. So how to load a pipeline. So this pipeline we can load from the transformer package itself. So I loaded a pipeline, and now to this pipeline I'm saying I want to be I wanted to perform the sentiment analysis. Okay, so once I will do it, guys, I will be able to load the model. See, by default this particular model is being loaded, but if you want to load any specific model, that facility is also available. Now the model is loaded. Now if I'm passing this particular sentence to my classifier, so see, it is able to classify it as a positive sentence. Now here I have written one more sentence that mera dost Don hai. So if I will check with the the polarization score of it, so it is simply saying that this sentence is a negative sentence. Okay. Now I can write this particular sentence in such a way right after the loading I can pass my messages. Okay, and with that I will be able to get a result. So here Hugging Face is awesome. So I'm getting a result as a positive one. Now not only this model, we can load so many model using this pipeline, and every model using this pipeline. So the next one is going to be zero shot classification. Zero shot classification means we can provide a label. Okay. So here, guys, we have provided a label while we are going to be perform the classification. So I wanted to classify between all these three labels. Okay. I'm not going to be classify my sentence apart from this particular label. So I given the candidate labels over here. The sentence is belonging to one of the category, either the education or the politics or the business. So let me execute it, and here is my result, guys. So as you can see, this I will be getting some probability score with respect to this particular sentence and this particular level. So let's see to which level it is showing the good probability score, and that will be my final answer. So the model is still loading, and here you can see we are able to load this classifier also. And here, see, this is my label, and this is the score with respect to that. So what was my sentence? My sentence was this is the course about the Python list comprehension. So if you will check, so education probability is coming very high, business is very less, and this politics is very less. So this sentence is belonging to the education category. Now there is a next one, text generation. I can load the text generation model also. So if I'm not going to be provide any specific name, so by default it is going to load the GPT-2 model. Okay. So after that I can provide my sentence, and it is going to be generate the further text with respect to this particular given question. So I'm just saying Python is a simple language. What is your thought? And yes, my model will be able to generate the answer related to that. I can utilize the other model as well. So here you can see this model is not very good with the generation because it is just a GPT-2 model. Now I can check with the other sentence also. So let's say, hello, how are you? Maybe I will get some prediction. So yes, it is giving me a little good prediction over here. Now, similar to that, I can perform the summarization also. So by default, it is going to be load some model, but I can give any custom model name as I told you. So here I given a text, and then we are going to perform the summarization, and I pass the max length also. Okay. So guys, here I'm going to be load one model. The model name is going to be log T5 T global base, and this model is specifically for the summarization, and this is the complete configuration of this model, and it is based on the Google T5 model, and for sure we can perform the summarization of it. Okay. So see, the pipeline is running, and we will be able to get a summarized result. Okay, so here also same thing, summarization, and it is going to be run, and see, we will be able to get a summary. Now similar to that, we can load the question answering based model also. So actually, guys, if you will go and check with all the parameter of this pipeline method, you will get a detail. You will get that we can provide the task, means which task we want to do. So we want to do the text classification, or we want to do the text generation, or we want to do the summarization, or which model we want to be load, which tokenizer we want to be load. Even though this is an optional one, means by default you will get some model over there, but yeah, for sure you will have to be mention the task name, which is a mandatory one. Now apart from that, some other parameter is there. You can go and check, you can explore that, and for sure you will get a clear cut understanding if you are going to be use this pipeline anywhere. Okay, so I hope guys you understood it, and see, this is going to be load the summarization model is still, and we will be able to summarize our data. Similar to that, we have a question answering based model. It is going to be load any by default model, which is a distill bird, but I can load any custom model. I can provide a name over there. Okay, so let it complete guys, then I'll show you the further thing. So over here guys, you can see we are able to print the summary. Now I'm going to be load the question answering based model. So yes, model load will take a time, and yes, let it complete, means I can do some prediction. And see, prediction is part also I have written over here. So I am saying where do I work. So this is the question, and here is a context. So I'm providing a context, and according to the context it is going to be generate an answer. Okay, now there is one more thing guys. So let's say if we have too much data, so which model we should use? Should we go ahead with the bird model, or should we go ahead with the distill bird model? Why I am showing you this thing, because the inferencing time, okay, the prediction time matters a lot. So here guys, what I'm doing, I'm taking 100 sentence. Okay, inside this text variable we have 100 sentence. Now what I'm doing, I'm going to be create a pipeline with this particular model bird based on case, and if I will check the time of the prediction, okay, like how it's going to be perform the like the sentiment analysis, so you will get it is taking 4 seconds with respect to the 100 sentence. Like on the other hand, we are checking with the distillbert model, and here you will see that it is going to be take a less time. So it is just taking a 3 second, right? So guys, we have to do the optimization also if we are going to be load any model. So we have to check which model is working faster, and yeah, for sure that the accuracy is going to be negotiate little, but again, we will be able to do some faster prediction and all. Okay, nowadays guys, we are going to be use some good model. We can use those particular model as well. I will show you that while I will discussing the this Langchain with Hugging Face. So we are going to be load some good generation model from the Hugging Face, and even will provide the prompting also, like a specific prompt also to those specific model. So this was the earlier thing. Nowadays we are not going to be use this thing, because LLM is too powerful. We have a different API like Grok, Gemini API. Okay, we have Open Router and the OpenAI based cloud based model, which is way more powerful to this particular thing. Nowadays we can do anything using the prompting and all. So guys, we are just learning this concept, this pipeline and all, but we are not going to be use it very extensively. Okay, just for the context, like just for the familiarity, actually I am showing you this thing. From here, which concept you can pick, so you can pick the optimization part. Okay, we have to load that model which could perform the prediction in a faster way, the inferencing in a faster way. Okay, now guys, let's discuss the very important part, the evaluation matrices, because everyone wants to be understand that, and everyone wants to be integrate this thing inside their application. So guys, for the matrices, we'll have to install this evaluate, this rough score, and this evaluate visualization. This three library is important. Now one more is there, Dataset. So I just install it so that I can load any dataset, and I can train one model, and I can show you how to calculate the accuracy. So first I'm going to be import this evaluate. So after importing this evaluate guys, from the evaluate itself, I'm going to load the accuracy metrics. Okay. So here guys, I'm going to be compute the accuracy. So accuracy dot compute, and here what I have the prediction. This is my prediction, and this is the references. Okay, now 0 1 1 0, this is the predicted value, predicted labels, and 0 1 0 0, this is my reference label. Now once what I will do, see, I will capture the result. So here is my result guys. You can see there is a 75% accuracy, okay, in the given prediction and the references. Now guys, what I'm doing, see, this prediction references actually this one, this accuracy, actually it is related to that confusion matrix. You know, the confusion matrix which we draw in the machine learning. So where there only we were calculating the accuracy and the error, right? So it's the same thing. Okay, so we can discuss about those confusion metrics and all later on I will come, but the main aim of mine is to discuss the perplexity of a score, blue score and all. So we'll check that part. So here what I'm doing, I'm showing you one a practical example. Here I'm doing one thing. I've created one function, compute metrics. Here I will get the evaluation, like prediction basically. Okay, eval predict, and from here I'm going to be collect the logit and label, means the probability and the specific label. I'm going to be check which is going to be the higher one, and this will be my prediction. Now what I will do, guys, so here I am going to be check the accuracy. I'll be having the prediction, and this is my original label. Now how I will get that? So here see, this is my compute matrix. I'm going to be like load the data set. I'm going to be load the sequence classification, this tokenizer, and that's trainer and training argument. So I'm going to be like fine tune one small model. Okay, so here I have a loaded a data. So my data is from the MDB, and I just taken the 100 rows from here. So train data set and test data set both is here. And now guys, I have a model also. So the model from the from the auto for sequence classification, this is a transformer based BERT model, and this is a distill BERT model actually, and the number of label is 2 over here. And here is what, here is my tokenizer from the like the distill from the it is the same tokenizer, the distill BERT tokenizer. Now I loaded up both. Now what I will do, guys, I'll tokenize my data. So after the tokenizing, here is my encoded data. Now what I will do, I will pass it to the set format. I'm going to be convert into the this one tensor or PyTorch specific tensor. Then this is my training argument. I'm going to be like, this is going to be my output directory. Here is my best size, and I no need to report to anyone, means I know I'm not going to be like capture the basically detail of the execution anywhere. Okay, so here is my argument, and this is my trainer. We are going to be discuss this all the thing in a detail in the upcoming session. Okay, because all the fine tuning and all is going to be depend on this trainer and the training argument itself. So here is my trainer. I'm going to be pass my model argument and this compute matrices. Now once I will train my model, see my training means I will have to start the like training. Okay, training trainer dot evaluate. So see, the trainer dot evaluation is done, and here I can check the metrics, right? The evaluation loss and the accuracy and all. So here my evaluation loss is this much, evaluation model preparation time is this much, evaluation accuracy is this much. Okay, evaluation runtime is this much. So it is giving me a complete detail, whatever I am able to get from this particular function. Okay, my main aim to get a evaluation accuracy and the evaluation loss, which we are able to get from here, from this compute metrics. Okay, now what we are doing over here, guys, so we are going to be fine tune, right? So we are going to be fine tune, means we are having the label by default label in the given model. Okay, and with respect to the given data set, we have a by default label, and whatever we are going to be retrain, right, those level of also we are going to be capture after the training. Means we are calling this evaluate now, so the training and all everything is happening, and those prediction level is captured over there, and because of that this matrix is coming. So it is working in this particular way in a real time. Means we can use this accuracy from the evaluate from the evaluate module in such a way. Now guys, there is an important matrix is everyone wants to be understand the uses of the blue score, rough score, and the perplexity. So here I kept couple of example, but before coming to this example, I would like to show you some theoretical stuff also with respect to this three matrices, and then guys I will come to this Hugging Face hub. So guys, I kept all the details and all everything into my notepad. So let's discuss one by one. I hope it is visible to all of you. So if we're talking about the blue score, guys, so see, this is the a blue score. See, there is all the formula and all everything you will get over here with respect to the blue score, perplexity, and the rough score and all. So first let's understand the basic concept behind it. So we're talking about the blue score, guys. So originally it was introduced while we were solving this machine translation task, and we can use this blue score for the generation as well. Okay. So this is the use case which have been mentioned over here. So the blue score basically it is going to be called the precision. As I told you guys, if we're talking about the confusion matrix. Okay, confusion matrix. So in the confusion matrix itself, we have a different terms, right? So we have a different terms. We have precision over there. Let me write over here precision. We have let me write over here precision. We have a recall over there, recall. We have accuracy, right? We have error over there. errors over there, right? So guys, this four matrices, this four basically important values we are going to be compute from where this four specific value we are going to be compute from the confusion matrices. So guys, this blue score is nothing, it's a precision of the n-gram overlap. Okay, n-gram means 1 gram, 2 gram, 3 gram. It could be any sort of a gram. This gram, basically here the gram is representing to nothing, it is representing to the number of words, the number of tokens. If I'm saying 1 gram means 1 token, 2 gram means 2 token, 3 gram is the value, the sentence with the 3 tokens. Okay, so let's assume we have a, so we are going to be check with a use case first, which is a machine translation. Now here I have a ground truth, so this is my ground truth. Okay, and this is my predicted output. Now what we are going to do, we are going to be calculate the blue score. So first they are going to be checked with the unigram. They are going to be match each and every word. Okay, one single word they are going to be match, right? So this is the score. Then they are going to be checked with the bigram. Okay, then they are going to be checked with the trigram. Okay, so sorry, bigram itself. And now in the bigram only they have find this particular word and this word is not going to be match. Okay, so here guys, like word by word it is going to be checked. So let's say we have a sentence, is Sunny is a boy. Okay, now here Sunny is man, right? So we have two sentences. So first is going to be checked word by word, means unigram of 1 gram, right? Then guys, it's going to be checked with the two words. So first it's going to be checked with the first word. Let's say Sunny is here, boy is here. Okay, so Sunny is going to be checked with the Sunny is and then boy. One words we are going to be checked with each other, right? Unigram. Then it's going to be combined two words. So Sunny is boy. Okay, it is going to be a man. It's not going to be a boy again. It's going to be a man, guys. So let me write over here man. So guys, it's going to be checked is Sunny is, then is boy, then Sunny is, and this then is man. Okay, now over here you can see, so Sunny is going to be matched, but is boy is man is not going to be matched. So here we have a contradiction, right? So guys, likewise this is going to be checked. As of now we are not going to be checked with the mathematical explanation of it. I'm just giving you the functional overview of this blue score and the other matrices. Later on we can discuss the mathematical implementation of it, as I shown you the formula of it. So blue score tells how much model translation overlap with real human translation. So if the blue score is high, means there is a better translation. Now it could be used for the text generation also. So here you can see this is the text reference output, ground truth, and this is the model output. So again it is checking in the same way. It is going to be checked first word by word, and then it is going to be checked basically with the two word combination and three word combination. So here you can see in the word by word only it is not going to be match something. So in based on that it is going to be impact to the score of the blue score, right? So blue is a helpful in evaluating the factual text generation but not ideal for the creative text. So generally we don't use the blue score for capturing the text generation and all. Initially this blue score BLEU, this particular score have been introduced for checking with a machine translation. Okay, now if you want to check out the formula of it, so here is the formula of the blue score. BLUE means bilingual evaluation under study, and this is a formula and the complete explanation of the formula. I'll show you this thing in some other other video. I will create one separate video for the evaluation matrices. Okay, now guys, here you can see, so we have other score, rough score. Rough score, basically it is a ROUGH. Rough score, it is mainly to calculate the like the same thing based on the recall. Okay, so recall and precision is both a thing basically comes from the confusion matrix. If you are not aware about the confusion matrix, so it looks like this. So I'm just showing you for the binary classification. So here guys, I would be having the actual value, and let's say this is true, this is false, and this is the predicted value. There we have a true and false, right? So let's say true means it is going to be 1, means it is going to be true positive. This is going to be basically a true negative. Okay, this is going to be this is the actual one, right? So it's going to be a false positive. Okay, so predicted is a positive but actual is a false. So it's going to be a false positive. Okay, false positive, and this is going to be a this is going to be predicted is a false, this is going to be a false negative. Okay, it's a negative, but this is a false negative. This is a positive, but it is a false, like it is a, it's like a actual, it is a actual, it is a false, but in actual means in a predicted way it is true, right? So it's a false positive. So something like this, guys. This is the like confusion matrix. With this particular matrix, you can easily understand the accuracy. You can easily understand the recall. Okay, precision also, and the error part also. Okay, so this all the term we can understand, and later on we'll see those one. So if we are talking about the rough, so mainly we were using this rough score for the summarization, and we are going to be calculate the recall over here. Okay, instead of the precision. Now here, guys, if you are going to be check with the formula, so this is the formula of the, see, this is the full form of the rough: recall oriented understudy of Gisting evaluation. Okay, Gisting evaluation. And if you're talking about the recall, so it is working on the same ideology, and this kind of formula only we were using over there. Now the third one, basically it's a it is a perplexity. So this is the formula of the perplexity, guys, as you can see over here, right? And let's look into the flow of the perplexity, that how it is working. Perplexity, basically it is mainly for the text generation. So we are going to be check the quality of the text generation. So for checking the quality of the text generation, we were mainly having this perplexity. So using this perplexity, we were checking how confused the model is about the next token. Okay. So a use case is causal language modeling, GPT type modeling, means the text generation. And here you can see the use case. So let's say this is a text example, the cat sat on the top. Okay. Now model is supposed to predict next word. So mat, carpet, and roof. So here you can see some score is associated with any sort of a word. So model is confident about the, model is confident means low perplexity. But if model is likely, but model is like means mat is 0.4, roof is 0.3, banana is 0.3. So model, if model is confused, means there is a high perplexity. Okay. So what I want to say over here, what I want to like, what I want to try, what I want to say over here. So here you can see the probability is very like the distinguished, right? So let's say if we are talking about the mat, so mat is showing 0.9. If we're talking about the carpet, so carpet basically it's showing 0.05. Okay. Now over here roof is showing 0.05. So clearly we can see mat is winning over here. So here we will be getting the low perplexity. Okay. If the model is confident, what needs to be predicted next? If model is getting confused, okay, so mat is 0.3, roof is 0.3, banana is 0.3. So model is confused over here. So model, if model is confused, means high perplexity. So in short, we can say perplexity is using during the training and validation of the LLM model like GPT, Llama, bot, and all. And guys, if we have a if we have a low perplexity, if we have a low perplexity score, in that case we can say our model is good. Our model is good in terms of the text generation. If our perplexity score is high, in that case we can say our model is not good. Okay, our model is not doing good, our model is not good. Now guys, on which formula, based on which formula it's going to be do this each and everything. So this is the formula, guys. Okay, so here like use case language modeling, a measure how surprised the model is by the actual text. Okay, so lower is a better, it's a more confident, and using this formula we are going to be use it. So n is representing the number of token, and p, wi, and W bit is less than I, predicted probability of the word. Okay, so here guys, using this formula we can understand the further example and all, but it is just a overview and the flow, like how this score is working. It is just taking a ground truth as well as the predicted output, and is going to be checked. This blue score and rough score is going to be match the unigram, bigram, trigram, and all, and based on that is going to be calculate the score. But the other formula like perplexity, what it is doing, it is going to be check the probability of the next predicted word, and based on that it is going to be calculate the perplexity score. If we have a lesser perplexity score, means model is more confident, and our model is doing good in terms of the text generation. I hope guys you understood this entire thing. Now let's look into the practical. So what I'm doing, guys, so first I'm going to be check out with the first I'm going to be check out with the uh, this one uh, uh, this one blue score. So I'm going to be load the blue score. Here is my prediction, guys, and here is my references. I'm giving my prediction and references, and then I'm going to be print the result over here. So once I will print the result, guys, so here you will find out the result. So blue score is showing 0. Okay, precision is this one, 0.7, then 0.5, 0.2, and then 0. Then there is one more score, brevity penalty, that is 1.0. Length ratio is this one. Okay, translation length is 7 over here, and reference length is 6. Okay, so each and every metadata you can capture. Now let's understand why it is giving us 0. So for that I kept the explanation over here. So guys, as I told you, it is going to be checked first as a unigram, then bigram, then trigram. So in unigram, 5 word is going to be matched from all the 7 word. In bigram, 3 word is going to be matched. In trigram, one trigram set is going to be matched. But in 4gram, guys, it is not going, there is no match. Okay, so that's why this fourth value is coming 0. So over here, because of that only, guys, you will find out this final blue score is a 0, 1. So precision 0, here you can see this 0.71 means it is a unigram score, it is a bigram score, it is a trigram score, and it is a this 4-gram score. Okay, and the final score, if the 4-gram score is 0, the final score is a 0. So guys, it is just checking up to the 4-gram only, and if the any of them is coming 0, so the final score of the blue score is going to be 0. Okay, now there is one more thing, brevity penalty. Okay, what is a brevity penalty? Brevity penalty, basically it's a see that this is a translation length and this is the reference length. Okay, so it's going to be check the ratio between the translation length and the reference length, and this is the value which we are getting. Since candidate is longer than the reference length, okay, means the output is a like the greater than the reference length. Okay, so that's why this value is 1.0, and here there is no penalty. So this term could be little confusing, brevity penalty, and also better we can decode it later on, we can understand it later on. But I think you understood the crux of this blue score. Okay, the let this other term we will understand later on, this brevity penalty, length ratio I think it is clear, but the brevity penalty is remaining. So I will create one specific session just to explain you the evaluation matrices and all. There we can understand in a better way with some good examples. Now let me show you some other thing. So here is a blue score. Again we are going to be check, and I think you got to know how to calculate a blue score and why it is coming as a 0, 1. So you can check, this is the unigram, bigram, trigram, all the one is a 0, because here you can see the sentence is very mismatched to each other. Okay, the prediction and the reference means what? Ground truth. Now here, guys, we are going to be load the rough score. So this is my predicted summary, and here is my reference summary. Now we are going to be check the rough score. So here you will be able to find out the same. So see, rough score is what? Rough score is a 0.4 to 0.15, then L 0.4, L sum is coming around 0.4. Okay, so you can see the meaning of it. So rough 1, rough 2, rough L, and rough L sum. So 1 means unigram recall, which is this one, then bigram recall, which is this one. Okay, now here longest common sequence, so this score is this one, and here is rough L sum means sentence level LCS. Okay, so sentence level longest common sequence, which is this score. So guys, over here based on this particular score only, rough is giving me a the final evaluation. But here what will be required? We will be required the basically the references and the predicted value. Now what is the differences between this rough and the blue score? So the blue score, basically the full form, it is a bilingual evaluation understudy, and the rough score recall oriented understudy for Geisting evaluation. So it is focusing on the prime precision, it is focusing on the recall. Here n-gram type 1 gram to 4 gram precision, here 1 gram to 4 gram precision, along with this LCS. Okay, LCS means longest common subsequent. Then guys, here you can see formula style. So this is the formula. I think formula I already shown you. Okay, then brevity penalty, yes, penalize too short output, does not punish short output. So we can look into all this parameter in one of the separate class, and for sure I'll try to clarify best for this task. Okay, now over here you can see the task. Fell, when it is going to be fell, when synonymous used, multiple valid output, or extra irrelevant content is present. Now overlap type, so extract n-gram match. Okay, longest sequence, flexible phrasing. So guys, here now overlap type is a exact n-gram. Okay, So it is going to be checked with the exact n-gram. If it is going to fail, it is going to be generated 0. Longest subsequence means it is a little flexible compared to this exact n-gram. It is going to be checked the longest subsequence. That's why it is not coming 0. Okay. So multiple references supported. Okay. Interpretation, higher value is a good one. Higher rough is a good one. Used in, like we are going to be using this one. Metric value from 0 to 1 means from 0 to 100%. I hope guys you understood this entire thing. So as of now, my main aim to show you how we can use it through the Hugging Face evaluate library. Later on, we can understand this in a more better way. Once I will create a separate session on top of it. Now let's do one thing. Let's try to check out with the perplexity. So here is my perplexity. I'm going to be load the perplexity, and here is my prediction, guys. Okay. So I'm going to be check with the prediction whether it is correct or not. I'm just going to be check the generation out this generation quality. So here you can see the result basically is going to be load. So the result is around 42%. So mean perplexity is 42. So here it is giving me the 42 basically. So 42 is fine. If see, I written the length also. So what is going to be ideal value? So if it is a lower means less than 30% means it is good. If it is like more than 100, that means it is a confused model. Okay. So as of now, it is a moderate, means this generation is fine. We can keep some better sentence and we can check what the perplexity value is going to be. So to check the to identify the generation quality, we generally use the perplexity, and this is the ideal like metrics for that. Okay, because it is relying on the next word prediction, which we were using in the language modeling. In the language modeling, we were doing the next word prediction only now, and we are going to be check the quality of the next word, how better it is compared to the other word, means how reliable it is on top of the other word. Okay, and we are going to be check we are going to be like showcase that particular score in terms of the perplexity. Okay, now guys, so here I kept all the things. See, good is between 10 to 30, acceptable between 30 to 50, and here bad means more after 50, or like very confused means more than 100. I hope guys this thing is clear. Now there is a kind of plot which you can plot, which you can create. So if you have a accuracy, precision, F1 score and all, so I will be taking one session on top of the confusion matrix, where we can discuss about this accuracy, precision and all everything. Okay, with that your understanding will be more clear. So this kind of graph guys you can create, and with that actually you will be getting some idea in a visualized manner, that what this model A is doing, how better it is, what this model B is doing, how better it is. Okay, so prediction, accuracy and all everything you can predict at the single means everything you can visualize at the single place itself. So I hope this thing is also clear. Now coming to the next part, which is going to be Hugging Face Hub. Right after the Hugging Face Hub, guys, we'll understand how we can access the like Langchain Hugging Face. Okay, and how we can do the like the prompting and all, and how we can do the generation. So guys, here from the Hugging Face Hub, we are going to be import this Hugging Face API, HF API. Even though I shown you couple of like thing already from the Hugging Face Hub, but guys, this Hugging Face API is like very much important. If you want to be like directly load the model from the Hugging Face, just for the inferencing, you can do that. So if you will check with the previous classes like auto classes, pipeline. So with that, what we were doing, we were downloading the model in our memory, right? We have seen the snapshot download. Using the snapshot download, what we were doing, we were downloading the memory on disk, right? But let's say if you want to be like perform the inferencing, you don't want to be download the model in memory on disk. You directly want to perform the inferencing from the hub only. Then how you can do that? For that, there is a Hugging Face API. So let me show you the uses of this HF API, which we are going to be import from the Hugging Face Hub. In the starting of this session, I shown you the uses of the Hugging Face Hub for creating the repository and to pushing a file over the Hugging Face repository. So see, I was doing this using the Hugging Face API itself. I mentioned the token, that was a right token, and see, I was creating a repository and I was uploading a file over there. So guys, this Hugging Face API is very much important for creating a repository, for pushing a data over there, for getting a detail of any sort of a model, and for doing the inferencing. So first, let's do one thing. Let's try to create an object of this Hugging Face API. And then guys, what I'm doing, I'm going to be pass this model name. My model name is going to be bird base uncased. So API dot model info, I just want to get a detail of this particular model, and here I will be getting the detail inside this variable. Now what I'm doing, guys, I'm going to be check out the detail, right? So whatever detail I want to be capture, like card data, tags, SHA, right, means the commit, then last modified thing, then siblings, okay, model ID, likes, author name is private, downloads, everything, every kind of metadata I will be able to capture. Okay, so here, guys, you can see this is a model card metadata, then book corpus, Wikipedia, it's a detail about the model card, means like on which the data have been trained, then language in English, license tags, okay. So here you can see the commits, last modify, when it was last modified, files, model ID, likes, every sort of a metadata we are able to capture. Now, guys, we can apply some filter also. Let's say if I'm going to be use this API.list model, if I'm going to be check out with the, see, if I'm passing this emotion, and short is what, short is a downloads, right, and limit is equal to 5. So what we'll be getting over here, we'll be getting all the model name which is for this emotion detection, okay, and which is a downloadable one. So what I can do, I can simply execute it, and here I'm getting a list of model. So see, I'm getting 5 model, which with that actually I can perform this emotion analysis, and we can download those one. Now apart from this one, see, I can put a few more filter. Let's say if I want to get a model, the text generation model, here I am putting a limit is equal to 10. Okay, short, basically short means like you can read out the detail over here. Basically you can hover the mouse on top of it, you will get all the variables. Okay, and one by one what you can do, just a second, let me uh, keep my cursor over here, and then slowly scroll down. Now once you will scroll down, guys, you will be getting all the variables. See, filter is here. Okay, now apart from this one, you can see if gated, true, pass, right, and then the definition of other filters. Okay, so model on hub is there, and pipeline tagging emotion carver created, order while expanding parameter possible value, SHA, user information, disable runs. So here, guys, filters, basically it is providing a list model with bird in their name. Okay, so here, guys, we are see, search is also one of them, means if any specific on based on any specific terminology I want to be search, I can do that, right? Author is Google. Okay, we can provide the author also. So different parameter basically we can pass over here. Okay, now what you can do, uh, give me a second. Okay, so guys, here you can see the definition of the short. So short means what? See, just carefully see into this definition. So short means the key with which short the resulting model. Possible values are last modified, trending score created at when it was created, downloads and like. So here we are going to be short based on the download, like how many downloads have been done, right? How many downloads have been done like in our recent days. Okay, based on that basically we are going to be check out, we are going to be like short the model. So here is my model. So here this is the result. See, this is the model, GPT-2 model. The download is around more than 1 cr. Yeah, 1 cr 44 lakh 26,000. Okay, then there is other model like Coin, Meta, Llama, Facebook, Jensen, Distilbird and all. So this is the other model which you can see, and the filter which we are getting means the value we are getting based on the download, how many times basically it was download. See, this is the same thing. Okay, so short means how many times the model was download, which is able to detect the emotion, and limit is 5, right? Now I hope this is clear. So I can get, guys, I can get the detail of the repo also. So what all files is there inside the repo. Let's say I provided this particular ID Google, from the Google, there is a repo for this model, from this model Flan T5 base. So I will be getting all the files whatever is there inside this repository. Okay, so I am having this git attributes, readme config.json, flags model generation config.json, model save tensor. This all the file is available over there in the repository of this particular model. Even you can check out with your repository that what all files are there. So see, in the data set I just only have one file. In the other models repository you can check out with the file. So you will be getting the different files over there. Okay, So let me show you one of the repository. Let's say this repository, which is a fine tune one. I only perform the fine tuning of it, and see, this is all the files which is available. So if you are going to be check out the files, whatever files is there, simply you can check out with this particular method. Then API dataset info, you will get the info of each and every like you will get the information of the data, whatever name you are going to be mentioned over here. Okay, so summary is not available. Then the files you can see over here, the files again in a Parquet format. Now guys, over here, if you want to be like download any model, see from the Hugging Face Hub, the method is hugging hf hub download. Okay, now from this particular hub, right, I want to be download a file. So what I'm doing, I'm going to be download the specific file. So here guys, you can see I'm going to be download a specific file. The file name is what, this config.json, from where, from the bird based uncase. And while I'm going to be loaded, so here is a detail from the file that hidden state size is 768, means I'm going to be download the configuration from this particular repository. Okay, and the configuration we are going to be what guys, we are going to be download the configuration from this repository, this bird base uncase. Okay, and the file name is what, file name is this config.json. Okay, and then what I'm doing guys, so here I'm passing a path, like I'm passing this config path, and I'm going to be load this particular file, and see from here I'm getting a detail. So I can simply show you whether this file is coming over here or not. Once you will refresh it, you will be getting that particular file. Okay, I think it's not coming in my, you can check out guys, you will be getting that. And then guys, you can even download that, and you can get the like the rest of the detail. Okay, now the next one is the inference client. So using this inference client only, we are going to be load the model from the Hugging Face. Okay, so inference client, we are going to be load from the Hugging Face hub. See, this is a model name, and here I am writing client.text classification, and it is able to perform the text classification over here. We are not going to be download the model in our local, we are going to be simply take the model from the Hugging Face server only, and we are able to do the prediction over here. Okay, now guys, we can take some other model also. So let's say if I want to take, see here you can check the complete detail of the model, like the tag, pipeline tag, which was a text classification. Now here what I'm doing guys, I'm going to be check out, right, what I'm going to be check out, I'm going to be check out with a text generation model, top 20 model of the text generation. Okay, so here you can see this is a model like for the text generation, as you can see. So first I'm going to be create a object of the API, Hugging Face API. Then I'm writing ap.list model, filter is text generation, limit is 20, right? Then here I'm going to be train on model, and I'm checking with a pipeline tag. If it is text generation, then I'm printing the model ID. Okay, so this is top 20 model from the text, for the text generation, which you are able to get over here. Now what I'm doing, I'm going to be load any of the models. So I'm going to be load a model from the Mistral AI, and it is an inference client guys. Again, I'm saying it is an inference client. We are not going to be download the model in local, or we are not going to be download anything guys in the memory as well. So here if I'm going to be run it, see this is what, okay, it is saying model Mistral.ai 7b is not supported for the task generation task provided by the Notipa. Support, okay, conversational task. Maybe some other method will have to be called over here. See guys, if we're talking about, see, this is my inference client. Here is my model ID. Okay, here is my client guys. Then I'm just saying client.text generation, and whatever like the input I'm giving, based on that I'll be getting a response. Let me check out with some other model. Let's say if I'm going to be check with a DeepSeek, let's see whether we are able to load this specific model or not. I think you know about the DeepSeek guys, right? So here it is showing the text and not provided, some Nova available task, conversation and feature. Maybe we'll have to call some other method over here on top of the client itself. Okay, we can check that. So this happens. So let me check out with the Microsoft this bitnet model. It is all the open source model. Whoever is doing the research and some fine tuning and all, they are just simply putting the model on top of the Hugging Face itself. Okay, so it is so this model is also not available. You will have to check on top of which one you can call this text generation, right? And with that you will be able to get the final detail. Let me check out with the coin whether I can take the coin or not for that final text generation. So this is the coin, and if I'm going to be check out with that, so again with the coin also. not found URL, make sure you specify the correct repo ID. Okay, I think this is having an issue with the URL itself. So just a second, guys. Let me check out with this DeepSeek 0528 itself, and I can check out with the other method, the conversation and all. Okay, the task not the providers, summon Nova, available task conversational feature extraction. Okay, so let's do one thing. Let's keep this out in some other uh, basically cell. And here what I'm doing, I'm just going to be take this response dot client. Okay, now let's see on top of this client what I can call. So here is the client. Now if I'm going to be press dot over here, so let's see. So text classification generation, text to image, speech, okay, visualization, zero sort classification, question answering, object detection, list, image headers, fill mask, feature extraction, cookie chat completion, audio to classification, product key, uh, conversational is there, any method is not here. Okay, question answering, text generation, text timeout, text class, visual, zero shot. Okay, guys, let's do one thing. Let's check out with this chat completion. I hope so it's gonna work. If not, guys, you can check out that which method is suitable for this one. I think it is all about the method only. The correct method needs to be called. So here client dot chat completion. No, guys. So this is also not going to work. I think, guys, you will have to check the method. Uh, let me let me check out that particular method. So here, guys, I solved this error and it took me around 10 to 15 minutes. So what is the error? Let me talk about it. So guys, whenever first of all, let me go ahead step by step. Okay, let me delete this one first of all, and then I'll go ahead step by step. Okay. So what you will have to do, guys, you will have to be install this particular version of the Hugging Face Hub. Okay, because in the latest version there are like couple of errors which I figure out. Most of the model ID right is not available. Means like there are a couple of provider. I'll show you what all provider is there. With respect to those provider, you will not be able to find out a specific inferencing endpoint. Okay, you can host your own application and then you can read out that that is a different case. But if you are going to be load uh, the already deploy model, right, so those you will not be able to get in the latest Hugging Face Hub. There is some errors. So guys, first of all you need to be update your package with this particular version. Now after that you have to be check. Okay, so where you need to go, guys, you need to go through with the Hugging Face Hub, this Hub Python library. There you will find out one table. Okay, so inside the table, guys, they have provided you different tasks. So you can see inference provider pricing documentation, supported provider and task. Now there is a different task. So inside this task you can see we have like all the tasks like image classification, segmentation, image to tag, object detection, question answering, summarization. Now in that, check out with the text generation. Okay, so this is the text generation. Now check out with the provider that what all provider is being supported to the text generation. Okay, so see cross and see the right this tick symbol. Just check out with the provider. So Hugging Face inference provider is there. Then we have the hyperbolic Nebis AI Studio. Okay. Then this Nobita AI, right? This sub Sem Banova, this provider is not there for the text generation. This Together AI is there, right? For the more detail, what you can do, you can go and check out with this particular method, and you can check the detail over here, right? All the like provider, all the parameter, classes, function, everything you will be able to see over here at this particular page, right? It is loading. So let me reload it again. You will be get that, right? So the first thing what you have to do, guys, you have to be update the version. Okay, the second thing you have to, guys, you have to check out with the provider. At the provider I shown you, right? So let it load. I think there is some internet issue. Let it complete, guys. Okay, now see guys, I'm able to see this particular page. So once you will scroll down over here, you will get the text generation method. Now what all parameter and all is everything is there. So you see, you will find out a different parameter inside it and the detail of it. Then you can check out with this the code snippet. They are providing some code snippet as well. Okay, and the complete detail you can check, right? So what I did, first of all, I downgraded the version. Then I checked the provider, that what all provider is there with respect to the text generation. In some of the provider, you will have to you will have to mention some keys as well. Okay. Then what I have done, guys, I have checked what all text generation models are there. I checked with the ID. So this code or this specific code, you can execute any of them. See this particular code for the text generation, all the text generation model you will get. Okay, so let me do one thing. Let me show you this as well. I think this is not required. I just tested out. So I just checked with the Gemini itself. Over here, you can see the support of the Gemini. So it was not able to give the answer. I tried very hard with the documentation and all. See here, it was giving me the models. Okay, so there is in total 17 models you will get. So if I'm going to be execute it now, see, this is all the model which I get earlier. Now I generated one more code. I checked with one more code and I took from the documentation also, and see, this will give you the list of all the text generation model which is there over the Hugging Face inference. Okay. Now if you want to get all the models, so simply you can uh, print this model. Okay. You will get all the 17 models. See, this was a model. So what a model is there, you can get the name of it, you can iterate the for loop and all, and you will be able to understand that. Or else let me do one thing, let me iterate the for loop. So for model underscore name, and here in, now what I can do, I can check out with the model ID. Okay, so this model ID I can take over here, and just a second, let me put the model name. Model ID is here, and then model name. Now what I'm doing, guys, so I'm just going to be write the print statement over here. So model name dot model ID. Now see, guys, you will be get the model ID for all the models. So this model is being supported, okay, for the text generation. Now any of them you can use. So what I did, I check out with the Llama 3.1 8B instructor, and guys, you have to be you have to like write the provider name. So what all thing you have to do to check out with any of the model. So first of all, guys, you have to be downgrade your Hugging Face hub version, right? So that you can see over here. The second thing, you have to check with the provider that for this text generation, what a provider is supporting, and you can get out the detail, the complete code detail and all parameter detail, the low level code detail over here. Then the next thing, you have to check what all a text generation model is there under the specific provider. Okay, that we can check with the code itself. So see, inference provider name, HF inference, and see, this is a like model name. Okay, now any of them, any of the model you can use out of it. Okay, over here, see, I have used this Meta Llama 3.18b instruct, and yes, peacefully and directly I am able to do the inferencing using it. So I hope, guys, this thing is clear. Now let's look into the next topic, which is going to be Hugging Face with Langchain. Okay. So guys, you will find out the like the Hugging Face wrapper on top of the Langchain wrapper on top of the Hugging Face classes and all. Means Langchain is providing the Hugging Face functionality under the Langchain itself. So for that, we'll have to be install couple of things. Let me show you all the thing over here. Okay, and the end goal which we are going, what we are going to be generate at the end, because this model we're gonna use for the text generation, and it's going to be useful. So we're gonna use this model in two way. So via the inferencing client, and the second is the pipeline. Means we can install the model in the local memory itself. Okay. So here, guys, you can see we have accelerate and bits and bytes. So yeah, this is fine. We are going to be install it. Then we have this Langchain Hugging Face and Langchain community. These two more package you will have to install over here. Now after that, guys, what is the next thing? So see, you will have to be import everything from this Langchain Hugging Face. So from the Langchain Hugging Face, I'm going to be import this chat Hugging Face, and from the Langchain Hugging Face, I'm going to be import this Hugging Face endpoint. This two thing. So what I will do, let me import this two thing after installing this entire thing. This like all the packages, whatever is there. It might take some time because this is a huge package of the Hugging Face itself, and this Langchain Hugging Face in the Langchain community, it is a main package from the Langchain which will make a main connectivity between the Langchain and the Hugging Face. And guys, one more thing, see, Langchain provide the integration with everything, whether it's a Hugging Face, OpenAI, Clouded, Together AI, or whatever, right? Whatever framework you can see. So Hugging Langchain is a very vast. Langchain is having a very vast ecosystem, and for sure you can take a model from the Hugging Face also using the Langchain. Okay. So let it download, guys. After that, we'll see how we can utilize the model from the Hugging Face through the Langchain, how we can use the capability of the Langchain like prompt template chaining and all for performing the text generation and all. Now, guys, this part is very much important, which I shown you earlier. So over here, you can see what we are able to do. We are able to take the real LLM model and we are able to do the generation out of it. Okay. So just check out with this code, check out with the text generation based model, and after that you can make a inferencing, okay, directly from those using those particular model itself. Now the same thing we're gonna see using the Langchain itself, so that we can use the power of the Langchain like chaining, prompting and all everything, which is the important part nowadays for building any sort of a AI application. Okay, so yeah, it's going to be installed. Let it complete, guys. Then we'll start with the further like coding and all. Yeah, so after installing all the packages, guys, see, I'm able to import this chat Hugging Face and the Hugging Face endpoint from the LangChain. Now, what I'm doing, I'm just passing my ID, right? Whatever model I want to be take, I want to be like load. And here the task is a text generation. That's why first I shown you the Hugging Face inferencing API. Okay, then I came to this LangChain, Hugging Face by LangChain. So then here is all other parameter, how much max token we want, do sample, no, it is not required. Repetition penalty 1.03 means how much repetition I can basically tolerate. Okay, so now I'm going to be executed and let's see whether I'm getting an answer or not. Yeah, so runtime got disconnected. It is like connecting again. Okay, without GPU as of now, like a GPU, I don't have access of it. Okay, so I think I reach out to my limit. Okay, perfect, guys. So it is done. Now let me do one thing. Let me take this chat model. Okay, see, I'm configure the LLM. I configure the LLM and then I pass it over here to this Hugging Face chat Hugging Face, and now I got my chat model. Now simply I can call the invoke on top of it and see I'll be getting a response out of it, right? So yes, my model is working fine, which I am loading directly from the Hugging Face. Now what I will do, guys, so here is my prompt template, here is my output parser, and here is my runnable pass through. So I'm writing a prompt. My prompt is I am getting a question. So give me an answer in detailed manner and in a step-by-step manner. So this is a simple prompt which I am appending over here, and see my prompt template is ready. Now this using this runnable pass through, I will take a question on runtime. Then I will be having my prompt, then my model, and then my output parser. Okay. So here is my LLM chain. Now this is my question: who is the first president of India? And then if I'm going to be invoked using this LLM chain dot invoke, I will be getting my answer. As you can see over here, guys, so it is going to be generate an answer in a refined way because I'm using output parser. I will not getting any other metadata except the text. Okay, I hope this is perfect. So likewise, we can load any sort of a model using the Hugging Face, and we can use the capability of the Langchain also over here, like the chaining, prompt templating, our parsing and all everything. Now, guys, this Hugging Face, this Langchain Hugging Face is having one more method, that is Hugging Face pipeline. It is similar to the pipeline method which was there in the transformer. Now let me import it. Now, guys, what this is doing, this is going to be load the model in a local system. Okay. So guys, as of now, see, this model is going to be very huge. So over here, what you will have to do, you will have to do the bits and bytes, means you will have to be load the quantized model. So this is the configuration for the quantized model. Then here is a LLM with that quantized configuration. Okay, after that, after loading the model, rest of the part is going to be same. Means you will be taking inside the chat hugging face that particular model, then the prompt template, then LLM chain, same, and then the same question, and here you will be able to get the answer. Okay, so let me revise it again. This Langchain with hugging face, that what all thing we have learned. So first thing we have learned that okay, how we can load the model from the API, right? From the hugging face, from the like the hugging face API, from the hugging face server directly, using that endpoint. So I have this chat hugging face, which is a common method, and then the second is a hugging face endpoint, which is like a wrapper on top of the inferencing client. The inferencing client we were learning. So we have mentioned the repo ID and all everything, the task name, and here you can see we are able to load the model, and then like here my model is working, and then here you can see we are able to create a chain out of it. So my template is here, then a chain means my runnable pass through means I will take a question on runtime, then I have a prompt, the chat model, and str output parser for the text parsing. Okay, then guys, see, here is a question, I'm asking a question and I'm getting my answer. Now guys, see, earlier we were loading the model directly from the server. Okay, we were loading the model directly using the endpoint. We were not installing it, we were not downloading it in our local, in our memory. But using this hugging face pipeline, guys, what we can do, if we will check with this particular method, hugging face pipeline, so we are going to be download the model in memory. So yeah, I have tried with this particular model, so the model was very huge, I was not able to download. So for that, what I have done, I have just written a quantized configuration, and using this quantized configuration, guys, I will be able to load my model in a memory itself. Okay, so as of now, I am not having access of the GPU. I will have to switch the ID and will have to run everything from scratch. So please, guys, it is a homework for all of you. Please try out with bits and bytes and this like try to load a model, and after that rest of the thing is going to be same. Right, you are going to be create a chat model, then prompting, you are going to keep it in a chain, and then you are going to be generate your final answer. The difference is first model you are directly going to be read from the endpoint, from the server itself, and the second you are going to be download in your local memory. Okay, so this is it, guys, for this particular course. I hope you like the entire course. If you like, then please hit the like button, please subscribe the channel. I will be coming up with many more courses like this which will help you a lot. And guys, this quantization bits and bytes, don't worry, in a very detailed manner we are going to be explore each and every part of it. So guys, as of now, I'm going to be stop the session. Rest of the thing regarding the fine tuning, hugging face and all, we are going to learn in the upcoming session. So thank you, bye bye, take care, I'll see you in the next session. Take care of yourself.